Hello everybody, welcome to another stream. How are we doing? So last stream, we got this occlusion, occluder volumes. Yeah, these guys, these white boxes, being constructed basically. So we've got this so we're trying to fix this glitch here. We just got too many spheres and they're just filling up our screen tiles. So here's this ball. And then this is not in the same place as the ball, but I can move it's not the same place or scale, to be honest. But this is the volume that goes around this ball here, essentially. And then these white volumes here are all the sort of the biggest, as we go down the LOD tree, they are the biggest volumes that are filled with spheres, basically. Hey there, Kip Payne. Thank you so much for subbing, my friend. I hope you're doing well and rested. Having a decent day. Yeah, man, doing good. Doing good. Having a great day. Yeah. How are you? How are you doing? Thank you so much for the sub. Appreciate it, sir. Yeah, today's going good. Yesterday, I got out a new version of the compiler that that I used for this project. So that's really cool. I was happy to actually. I didn't realize how much. Oh, okay? This doesn't want to click when. Yeah, I need to fix that when my game's open. My game sort of takes control of the mouse. It's like no. Yeah, I did like all these sort of bug fixes over the past 6 months or whatever, and a few features like Intel support and yeah. So got a new version of my compiler right now, which is great. So happy about that one. How's everything going with you? So as we get on the LOD tree, damn it. Yes, as we get on the LOD tree, so this is the first LOD. It's got one cluster in it, and then there's 8 children, right? It's an octree of children, which go down to more clusters. So essentially, if this root cluster is filled with spheres, this will become an occluder. And that's how simple we've done it right now. We can drill down into saying, hey, if half of it is full, that's an occluder. And search the other children. But for now, we're just trying to get some basic version working. So essentially, these are the occluders that are filled, but they're kind of jumping around quite a bit. And the reason why that's happening is because when you find the first so many, basically, make occluders. Yes, here's where I do the debug drawing code. Yeah, so when you have like 250, basically, that we are essentially, yeah, 256, I think. No? Oh, I think it's even lower now. I've just changed it. So we're looking for 64 occluders, and when we construct the volume, and the problem is when you start filling up this array, because the GPU issues its threads is waves or its compute units in an unordered way. This array gets filled up with different data. So the first 32 that we take at the end are not the occluders, are not the same occluders, even if the data is the same. So what we need to do is to make it ordered. First, we need to have a big enough buffer. So we might make that like 256 or something. And we want to keep 32 of them at the end. So the first thing we need to do is actually sort the final bunch of occluders by how big they are. And then those ones we can keep. So I was thinking also offline, this is probably not the best way to store the occluder. We probably want to keep track of all the information. So we probably do want an LOD, we probably do want a cluster coordinate. We probably do want a sphere. Wait, do we want? Yeah, we probably do want a sphere min-max. So the reason why we want it this way is so we have an LOD tree. LOD 0 covers the whole. It's not 256 cubes anymore, it's actually different. Let me get the eraser out again. I swear I changed that, but I must have undone it. Actually, 1 to 8. Oh. 1 to 8. 1 to 8. There we go. Hey there, Ren Goblin. How you doing? How you doing? Yeah, I'm doing good, man. Doing good. Got a new version of my compiler right now, so happy about that. It's been about nearly 10 months now since I released an update for it. And doing some occlusion buffer stuff today, so we should be able to see this in action. Right on. I'm doing good. New job seems pretty good. Nice. Job isn't program related, but expected, of course. That's cool. I'm glad you're at least happy with the job you have. That's great. That's where you want to. That's kind of where you want to be, is at peace with the thing you do every day. You know. But yeah, keep working on some stuff in your spare time. I'm sure you'll land something program related as time goes. Yeah, pretty good. Some of these Linux and Proton bought my game and told me that it's working for them, and he was shocked. Okay. Yeah, Proton's pretty good these days, apparently. I don't know, I don't really play many games on PC. But yeah, supposedly it's quite good. So it's 1 to 8 cubed. Space L0 fills up this whole space. Basically, right? So it's a 4x4x4 set of spheres. So if the whole volume is completely filled, and then we make this an occluder, right? These spheres are bloody big, right? And they fill the space, right? So you will, when you put the occluder down, it will be something like, there should be a fourth one here, but anyway, you get the point. Is something like that. Now, as you go down the LODs to the higher levels of detail, what you'd actually get is 4 more here that cover this whole sphere. This breaks down. Wait, no. Sorry. 1. You get 1, 2, 3, 4. Yeah, you get 8 by 8 by 8, right? So really, as you get in the LODs, this occluder is actually bigger now. It goes here. Yeah. So you need to move it out. Basically, just slightly. Yeah, the occluder gets slightly bigger. So we need to account for that, basically. So we store the LOD information and the coordinate within that LOD, then we can essentially change it as it approaches, or depending on what depending on what though, what's the metric? If we take the, because the whole volume, yeah, it's kind of an optimization, but I guess No, it probably... Hmm. Because the issue is with a volume, well, the great thing about the volume is it all could be a different level of detail. So this half of it could be at a higher level of detail, and this bit here could be at a lower level of detail, because the camera is closer to this side here. Um, mm, so when you render your occluders, yeah, maybe actually we'll undo that. We'll just keep it at that. And let's just see how much of a problem it becomes. Exactly, man, especially since my wife and I are trying for a kid. So I can watch some Star Wars here soon too. Nice. Yeah, I'm just getting close to the end of Star Wars Clone Wars. Let me just open up that window. It's a bit warm in here. So I've been whacking that on and watching it with my boy, and he's been every time he hears the intro now, he's just all like looking at it like just yeah. So he recognizes the Star Wars intro now, which is great. So I want to write a quick sort function. Let's take a look at my inputs to the shader. Cool, so we're just trying to sort this occluders buffer. So we're just going to brute force it a bit. Just do a very quick and dirty sort. So we have like a DST index, I guess. And then we're reading a bunch of source indices. Oh, what am I doing? Yeah, so we'll just go from yeah, what we're doing. How do we know how many occluders we got while we're doing this thing? Here we go. Occluders count. So the thing is, we've got like 32 threads helping us here. So I guess we'll leverage those, even though this doesn't have to be fast, because this is only meant to be called once per every time you build a volume. So I guess it doesn't have to be the best sort function. So essentially, we'll just do we'll have the outer loop scan over the whole buffer, and then the second loop scans over the whole buffer again, but starting from the destination slot, and it's looking for the smallest one out of all of those, and it will commit that into the slot. So at the end here, you're going to say BC occluders, and we'll have the occluder actually here. Wait, what was it called? Volume or cluster occluder? What was it called? I've got these names, these things already. Volume occluder. So just looking for the biggest occluders. Or, yeah, best occluder. So you just say destination index equal that. So yeah, it's not the best algorithm, but that's cool. So we need to have this one search 32 at a time. Wave threads count. So that's going to skip 32 at a time. And we can do a wave we should be able to check 32 at a time and sign that, I think. So you want to basically say if so you want to get your local, your sort of so you should call this like base source index. Then we'll call this source index. This is local per thread. That'll just be like sv dispatch index.x. So you're saying, okay, if this one is, if source index is less than occluder's count. Oh, that's close. There we go. Sweet. So now in here we can do the check. So how do I know which is the sort of the best occluder? So I'm just thinking the biggest, right? Yeah, I'm just thinking we want probably just the largest occluder. I was thinking like closer to the center of the object, but then I was thinking maybe further away is the better occluder to use. In some regards. So yeah, maybe we'll just pick the biggest occluders. Oh no, you have to have another metric, because a lot of them will just be the same size. So we might pick distance to the center then, because it's the other way you can measure it. So we need to somehow, you can't just do, so you want to say like, so how do you communicate across all the... Yeah, I don't know why I'm trying to write so optimized, but maybe it's just a good way to figure it out, or just to learn. So let's look at our wave intrinsics, because we can't do wave active min, because if we did that, we need to do two threads need to know. Sorry, there's two things we need to check, and it's not necessarily a min operation. On this one here. Sorry, it's it's a max actually. So we need to find the maximum size of that. And I guess the ones with the maximum size, those ones can then figure out which one is the closest to the middle. Yeah, maybe, okay, it's actually probably quite easy. So what you can do is you can say, right, given wave active max. Have I done a vector? I've got vectorized versions, great. So I do wave active max this, and we want to say, right, where's the current occluder? So we get the current occluder. So BC occluders source index. So you just do occluder dot half dims. The problem is that's not going to be good. It's not going to give you like, because if one thread has a 159 or whatever, or 8, okay, and another thread has 8.2, the result of that across all threads would then just be 888. Right, it wouldn't pick the best one out of all of them, it sort of merges them all. Pretty sure that's the way it'll work. He gets the max, it's like a... So that's probably not a good way of... So there probably isn't a good way to do a comparison across... See all the So you probably have to do it one element at a time. You do wave active max dot x equals myself, right? And See, I'm not sure how better this is, but anyway. And Z. Then you do the other parameter as well. What's the other one? Center position. So with center position, we want the one that's sort of closest to. So I guess we can go into the statement here, and we can just get a new local variable. This one we probably want it to be. So the middle of the so the middle of the space is 64 now. So position from center. So that'll just be like a subtract. So going towards occluder center position from some vector 3 of 64. So we kind of want to say which one is the then you want the absolute, isn't it? So you want to see which one here is the smallest. So it shouldn't be one of these that end up. Is that true though? Oh yeah, because if they're all the same, so this is the biggest size. So which one is the closest to the biggest size? The problem is you could probably get 2. Yeah, you could probably get 2 or more that show up. So I guess you just count the results, and then those were the ones that get added on to the end. So it's not a best occluder, you probably get many best occluders. No, still, you just pick one. Yeah, just pick the first one. So you can just now do if. Just amend that. So we're looking for an atomic min here. Which one is closest to the center? So which one is the biggest and closest to the center? This one. All right, let's have a think about this. So you can have multiple threads actually get here. Yeah, I guess you would. Yeah, I'm not sure why I'm trying to optimize this, to be honest. But it could be quicker. You're checking 32 at once, but I don't know. But yeah, you're going to want to take the results from that, maybe store it in a local variable. That'll be different on each thread, probably. Um, or you could probably keep note on which thread has the one that you want, and read it from there or something like that. Yeah, maybe let's just not multi-thread it. Let's just get it working, see how bad it is. I think we've got an idea of how we could do it if we want to make it better, or I guess we'll just use a more generic sort function like a radix sort or something. But yeah, so effectively we're looking for do something similar though. So you get your sort of best occluder. Um, um, so you probably want to have this sort of position from center, and you make this like S32 max. So that's the thing you're comparing it against. And the so you probably want to have this zeroed, I guess. So you zero all of those things, so half dims would be 0. Yes, the thing you'll be comparing against is probably your best. So this occluder versus best occluder. So this is greater than best occluder dot half dims dot x. Let's repeat that. Y, Z. Then I think we'll grab the. Maybe we'll do this as well. We have a separate thing. You work out position from center, and again we'll do that same thing where we'll say this is best position from center. If this is less than best position from center, then we update the variable. Now we only really want one thread just to do this really, because yeah, so it will just be, it's going to be really slow, but it'll work for now. Best position, best occluder, there we go. So I think that's all we want to do there. So let's just double check that. What's that indent plugin? Seems like an arrow. It's not really, it's not a plugin. You're basically trying to find the sum of x. Find the biggest sum. Maybe actually with the half dims. Yeah, probably actually I'm looking more for like a volume, aren't I? Like meter cubed. How big something is. Yeah, it's probably actually a better way to check it. Thank you, Campaign. Merging. So basically, this is native to Vim. I think it's in my .config. I forgot what they're called now. Here. So if you take a screenshot of this, right, it's basically list chars. If you don't use Lua for the config, you can do it in the other one as well. But yeah, you enable list and then list chars. This is UTF-8, and you basically, and this is space. Did that actually help? Yes, I think you have. It's using list chars basically, and these things just display the invisible characters as a sort of a comment looking thing. It's quite nice to see when spaces or tabs are there. Yeah, so actually we actually want to probably do a multiply element. Wait, product. Oh no, what's it even called? I forget my mass function. But yeah, we want to do like yeah, product elements. I know what I'm talking about. Product elements 3. So you're going to say x times y times z. And you want to do that for with the best occluder and the other occluder. And that is saying, hey, if we've got a bigger volume, yeah. And then this one is saying like, this one is probably a length operation actually. Yeah, I don't know why I didn't think about that. So we actually want to convert this to you probably want to convert that to a float. Did I change HMass or... There was a float initializer I think I changed. Yeah, float 32 cast, that's what I called it. So I think I can do this. Yeah, that'll do it. So then that'll be point F. So then we do it with floats instead, ABS with a float. And then that'll just be a length to center, F32, len. Yeah, that's the better way I think. Then that will just be a single scalar. So maybe it is possible to do that multi-threaded thing a lot easier now that we was trying to do. Because we're just literally working with scalars now. Yeah, let's just see how painfully slow it is. If it's painfully slow, we can always change. Always improve it. So if that is less than the best one, then we are now the best. Easy as pie. Okay, so I think that's right now. So basically we go over all the destination slots and we go say, hey, we're going to find the best one for 0. And we go and find the best one for 0. By starting off at the search place from where, yeah, so we include the destination one and start from there and search all the way to the end. Yep, find the best one and voila. Infinity. Okay. So I've got to improve this now. What was this again? Oh yeah. I'd have to make that on Earth. Right. So apparently that should sort it. Right. Let's give it a go. Right, so now they're sorted apparently. The only issue is... Right, why are we seeing more now? I've not... The draw code... I'm confused. Why are we seeing more, and why when this thing just... Wait, what's that? I forget that way to search for tasks now. Anyway, let's just do it this way. It's not showing up. It's taking control of my mouse and I can't use my mouse. What is going on? Where is the thing? That's it. Alright, now I've got control of the mouse again. That needs to be fixed at some point. Okay, so where are we drawing these bounding boxes? Oh, there's one drawn here. Yeah, cluster equals 0. Yeah, that's the yellow one. Okay, let's disable those and see if it runs. Yeah, we don't really see... I don't know why we were seeing more... Oh yeah, I said 256 occluders, didn't I? I increased the number of occluders to 256 instead here in the when we construct the volume, but we want to pick the best 32. Excellent. So I think we need to now pick the best 32. So I think inside our volume, we've now got a 32 occluders there. We just need to chuck them in. So because we've now sorted the array, I think, we're going to... So one way to check that is if we literally just dump the whole array out. So what we can do is do a print. So GPU hprintf, and we can just say index that, and we can do like a with this, that. So these are going to be our occlusion volumes. So we put in destination index, we then put in best occluder dot center position dot x, and we repeat that a few times, y and z. Then we do the same thing, but instead we do it for half dims. And that should be a way that we can literally just check to see that all of our occluders are sorted. So this should be sorted by the half dimensions first, then by how close they are to the center of the object. So where's our list? Good question. Oh, the sort occluders is not being called yet. Even though it's taking 14 milliseconds. Why is it taking 40 milliseconds? Oh, it's because we're just so damn close to the place when we boot it up, right? Yeah, the 3D render all the debug shapes. That's right. We're just so close to the screen, all those debug renders are just changing it. Cool. So we just got to fire this thing off. make occluders. Look for that. So this is where we make the occluders. After we make occluders, we want to call a sort. And then we will debug render those new ones as well. Probably instead. Better way of saying it. We'll use the same. When did I copy? Was it? Alright. Yeah, we're going to use the same constants. We're just going to use a different shader. So we're just going to launch one. We'll see how that goes. Synchronizing all those boys there. Good. And away we go. So this one's probably quite a slow shader, but we'll see how slow it is. Okay, it goes over 256 items or about. Yeah, it's actually quite a bit. Let me change that number down for a minute. Let's change it. Yeah, it's 256 times 256, and it does that. Let's change it down to 64 and just watch it. Just see how it is. So that's 64 times 64. Yeah, that shader's damn slow, isn't it? It's alright. Yeah, it's very slow. Plus we stuck a print in it. Wait, is that being populated too much? I just realized, what are we doing? Crap. This is a problem. It overflows, that's why it ran for so long. So this max occluders, we need to min this with that. That's why it was taking an extremely long time. Right. Did we get a... We didn't get a blink in the stream. Okay, that's good. Okay, so we're not seeing them sorted just yet, so they're still going to flicker because we rendered them before they were sorted. But this is with 64. Where is it in the? Okay, so it's not a lot. So we can up that to 256, and it shouldn't actually be that bad. That number might grow by about 8 times because we search over the rest of the array. Yeah, I don't know how many times slower it's going to get. Alright, so now we're picking two. So when we build the volume, we're going to find 256 of the best occluders, and then we're going to keep the best 32. Okay. And bear in mind, we haven't really got an algorithm that's good for picking the best quite yet. We just picked the volumes which are filled with spheres. Alright. So it's actually got way slower. That sort occluders, it got more than 8 times. Yeah. It got like more like 12 times slower. That's insane. We could make it better. Should we see if we can... but let's just check the results. Oh, we are printing out actually. We are printing out 256 times. That is probably a big part of it. So I guess we can just remove the print statement and that will be good. So it turns out it's picking... Why is it always picking the same one? Like, that's strange. Why don't we try this? Why don't we say, let's make best occluder equal to destination index, right? So it just yeah, it doesn't really change the order at all. I just want to see what's in the buffer. Right, so it has only found... There's actually only picked... Interesting. So the best one is here. Is at the start still. On this frame, I guess it can change. But yeah, so they're all kind of different. But so some do this code where we're... Right. We're meant to do a swap. That's why. Because we're meant to do a swap. So you're meant to say best occluder index. Let's say that's E32 max. Best occluder index is equal to source index. Then you're meant to say, hey, occluders, best occluder index. We already... Then you store the previous one back in there. Essentially doing a swap, right? We've stored this in the local variable. And then we overwrite the one we've taken, where the best occluder came from, with the one that we've currently got under our position. And then we store the best one in here. Okay, so that should fix it up. Right, okay. So... Right, now it's sorted. So you've got this. These are the positions. These are the biggest ones. So these ones are closer to the to 64 basically, and these ones are further away from 64. Right, that seems to be working good enough. So why don't we So anyways, why are we stopping at 42? Maybe. Yeah. Okay. So what we're going to do now is instead we're going to... What should we do? Where's the debug code? So we need to copy these two out, basically. Here you get 8 threads, which is not really utilizing the whole thing properly. This is a setup LOD, make persistence setup. So this could probably do the copy of the 32. So if I enable 32 threads, all of these boys will only happen for the first thread. Then the rest of them, the rest of the threads are going to copy all of the occluders out. So where's the thing? It's in volume, isn't it? Yeah, occluders count. Sweet. So what we're going to do is we're going to say, right, BC, oh, it's already here. BC volumes, occluders count. This is going to be equal to whatever this number is here. Do we get that? So is this min with that? So we plop that in there like that. Okay. Then we copy all of the occluders in manually. So here we're going to say occluders SV dispatch index.x. Then we'll copy over from the occluder So the occluders, SV dispatch index. So just essentially doing a mem copy, right? Boom. So there's 32 in one line of code because 32 threads doing it, right? So we need to put the occluders in here as read only. So let's go ahead and put that in pass it in CPU side. So it's the occluders, they're here. That. Then they are here as the sync code, read only. Nice. So that should copy the occluders in. Now what we kind of want to, what we should probably do is put the debug code here probably. So we can see it not flicker anymore. So this would be this renders the outer box. So what I kind of want to, where's the make here? So I kind of probably put this in some like if 0 type deal. So this is going to render that sort of out that box, and this one is going to render. See, it would be good if, yeah, you're just going to see it in the middle of in the world, basically. It's not going to be you're not going to see it for a particular volume instance because this is building an actual volume before it's instanced. So you're just going to see it in the middle of the world. That's okay. And it's kind of just scaled a bit bigger as well, I think. Insert index, so we probably want to take all of that. Like that. So again, we just find a volume which is filled with spheres and use that, but that will improve later. I just want to get this system up and running and see how good it is and stuff like that. So this is another debug thing. Wait, how many of these do we kind of want all of these back here actually? Nice one. So we'll render, we don't have the node though. So I kind of want to get my occluders actually. So I guess we've got to work out a bit differently. Volume occluder. Wait. This is a box going around the whole. That should be a box going around the whole volume. So that's quite easy to hard code. This one, however, is not. So let's get the occluder. Yes, this would just be 0 and 1. So that'd be a yellow box. Whereas this occluder is going to have a center position half dims, but it's not as floating point. It's not a snorm. It's snorm space. So this is not -1 to 1. So we need to turn it into that. So it should be occluder center position. So that goes to 128, 0 to 128. So we essentially need to divide it by volume dim, I think it's called. Yeah, volume dim 128. Thank you so much for the follow. I think we're nearing 4,000 now. 3 more, guys. So if 3 of you not following, press the follow button and be at 4,000. Thank you very much. 4,000 folks here. So that will get us 0 to 1. Then you just convert it to -1 to 1. Thank you so much. Appreciate the follow. So we times it by 2, then take away 1. Right, 2 more follows, guys, to 4,000. You can do it. So that gets us in Snorm space. We'll do the same thing again for the half position. This time it's a half dim. So because it's a half dim, you need it to be half of that, basically, I think. Alright. So no. No. Wait. So 64 will be a full, covers the full volume. 64 covers the full volume. So what? Yeah, if you divide it by 128, you've got a half, right? Then you convert half into sine norm space, which would be 1. And that's perfectly fine, so I need to divide it. Cool, so I think if we just take that and plop that into there, we should see a fixed set of occluders now. That won't change because we've sorted them and all of that jazz. All this can go. Doing some maths, you know. I guess I'm always doing maths. Good old maths. Why is there so many occluders? And why are they jumping around? And why are they too big? What's going on? Yeah. So you kind of also want to say, like, yeah, only do this, by the way. Only do this if is less than occluders count. Starting to learn to see now. Awesome. Welcome there, Dots. Oh, sorry, Dots to Attitude. Welcome, welcome. Maths is mathin'. Yeah. I'll be mathin'. But yeah, it's cool you learn to see what brings you to the world to see. And you don't see many folks doing that these days. So it's good to see you doing it. Is a mute only variable? You're having a laugh. It's a mute only variable. Oh my days, my compiler's helping me. I put this in lately. Oh yeah, bugger. So it was write only. So it needs to be rewrite. Bit of a... Maybe write only is just annoying. I don't know, bit of an optimization. This probably doesn't help. Okay. I'm still not fixing the problemo. Why are these things... Like... So first of all, we should probably undo everything. and grab that print statement. So we very sillily deleted this one. Eh. So then we'll just leave that commented out. So basically, let's plop that in there. Always comment that instead now. So I want to look at these and be like, why are they different? I guess it's because I've not. Yeah, it just finds better ones. No, it can't. It can't find better ones because it doesn't even find more than 42 or whatever. So why are they jumping around all over the place? So 48, 48, 80. Okay, so see that. How does it look? Previous frame. Exactly. So let's take this whole list up to 42. Let's copy that into something like here. And let's just have a look at the data and see like, so here's the last frame. Let's pick out the last few or whatever, 104, 72, 88. They're a bit different. Probably because they're all equal. So are they just Z fighting then? At this point. They're the 104s. There's some 104s here. 72, 88. Where's the 72, 88 one? 104 in the middle. $72, 88, 104, right? Oh, I don't see anywhere. Why is that result not there? So 88 is 104, 88 we should see as well. No, that one's missing too. Why are they different? So is there something wrong with the filling up code? I am confused. Probably learn some better systems eventually. Cool. Are you building your engine because you have a game idea that can only be done with custom engine? No, not really. I like building custom engines and things. I like building my own technology. Um, so see how it fills up this buffer then. You add, and you only populate it if that is. Then it doesn't process any of the children. Right. interesting. We kept 32. No. We haven't checked what the number is. We didn't check what the number was. That is interesting. If this overflowed with information, but then it's got a bunch of zeros in the place, that is weird. So let's have a look at that number. $36,000. Have I reset this thing? $32,000. Sorry, 3,600. That's what's within the realms of possibility. Maybe we should make occluders on the biggest. No, let's increase the number of maximum occluders. No, but still, why is it putting zeros in? How is it putting a bunch of zeros in there? Like, should we look at number 43? So we'll kind of want to say if insert index equal 43, because it never does any more than that for some reason. Let's print that out. Come on. Oh, DST index, I don't know. Right, do we see that pop up? There it is. The data clearly goes in there. 43. Right, so something bad's happening with my sort function. Let's change that a bit then. So with a sort function then, if we instead tell it to just put the destination into the best, let's comment those two out. We'll put the destination into best occluder instead and just view that. We won't change the order. Oh, are we overflowing? We're overflowing this buffer, I think. We only want to pick the best 32 of them as well. But anyway, this is going to print all of them. Oh wait, no, sorry. It's meant to sort all of them, isn't it? Yeah. That's the whole point of it. I feel like we're overflowing the buffer. Maybe the size of the buffer's not big enough when it's built. I'm using the wrong occluders. Oh, times U32. That's not good. It's times volume occluder. Size of that. Big mistake. Right, so that was the issue. I still wonder if 256 is big enough. So anyway, let's debug print those for now. I might have to up it a bit. I'm still seeing them jump about. These are not debug drawing the right size. The size of them is still way wrong. I need to correct that. But no biggie. But yeah, we're seeing full set of data now, which is good. I still think we probably need more. But if we did more... If we did more occluders in the construct, then the sort function is going to be too slow, I think. But anyway, let's do 512 and let's just see how we cope with that. Let's check the... It's 11 milliseconds now. Hey there, how's it going? I think that was... Oh, nearly one more follow. One more, maybe that was... Anyway, one more followers, guys, into 4,000. Thank you so much. Thank you, Simon Game Dev, for the raid. Appreciate it, sir. Hey there, Nekdos. And welcome, Aspect the Dev. How you guys doing? Thank you for the raid. We're just working on a occlusion buffer system. I'm just trying to get all my occluders ready. So picking the best set of occluders in a volume filled with spheres. And yeah, my debug drawing is a bit off, but this is our volume of spheres that we're trying to build occluders for. No engine. Awesome. Yeah. That's true. So we've also got custom C compiler that compiles to SphereV, so we use it for shaders as well, which actually did a release yesterday, a new release. So with C we can program it on the CPU and GPU, share structures and everything. So structures and functions with some limitations. And enums and all that, so it's very nice. Very nice. That number needs to be bigger, but my sort function is way too slow. It's slow because we've got the print code. If I take out the print code, how fast is it then? It just took off 1 millisecond, not even that. Alright, we can make it faster. So let's actually use the power of 32 threads. So we skip by wave count, which I was trying to do earlier, but I was thinking I was going to brute force it. So the sort function is dead simple, right? It goes over the whole array and finds the best one for that index by scanning the rest of the array from the destination slot index. We'll zoom one at a time, but now we'll do 32 at a time. So I think what we want to try and do then is... Yeah. So if we do a product of those, that will give us a U32 back. We can then do a wave, if wave active max U32, if that, would you want to say if that is equal to me? No, not really, that makes it, yeah, so you pick the best one. If that's greater than the best one we've got here locally, I guess those would be in SGPRs. You can work that out because that would be an SGPR as well. Okay, then you work this out as being VGPRs. Then you want to make it scalar across all threads. So all threads get the same value, they will then get the minimum between all of those. And if that is less than the best length to center. Now you want to know which index was the one that did this. So that won't necessarily work. You need to say if this is me, right? So you need to know which one it actually is that. So is me 0? Wait a minute. I need to get the actual value. Damn it. U32. This one be like... the volume cubed of the... yeah. Or of the occluder. Take the volume cubed, get the max. If that is equal to this, then that is me. So we want to take so that you want to do a similar thing here. You want to get the max version. And this be is me 1 with that. Then if is me. Now 2 threads can actually get in here. And is me 1. So in that case, you want to pick the wave active min of the source indices and use that one. That should do it, I reckon. So that should be 32 threads checking at once rather than 1, which will make the GPU far happier. Hey Simon, Game Dev, thank you so much for the raid, sir. How did the stream go? Isn't Vulkan supposed to be getting a pretty big upgrade? I thought I heard something. But NVIDIA drives releasing soon. Oh, really? Yeah, I don't know. You would think there would be something new soon because Vulkan 1.3 came out 2 years ago. 2 years ago before, or over 2 years now. So it's due. Because 2 years before that, Vulkan 1.2 came out. And 2 years before that, Vulkan 1.1 came out. So on. Oh, I want more of those actually to 1.0. So it is kind of due, but there's nothing big kind of... Yeah, I think we just got to the point of Vulkan where they keep trying to add these new extensions, which sort of make stuff easier, but then they just make the API more complicated. So yeah, I don't know where they're going to take the API next. Honestly, it would be just good if they were able to sort of like do a Vulkan 2.0. And basically clean up the mess of the API that they've made already, because it is kind of... the header file is absolutely massive and filled with tons of stuff. That is probably... yeah. Like, descriptor sets in Vulkan 1.0, like that is just no longer a thing that people use anymore. So we get like to 2.0 and just like deprecate a lot of stuff. Where did I put this thing? I put it somewhere, I remember. Oh, no way. I could have swore I put that in a header file somewhere. GPU shader maybe. Give me a number of wave. I don't even know anymore. You know, let's just copy what this thing did and put it locally. This is the way. Alright. So it should be sorting 32 threads at... well, comparing 32 threads at once. There we go. So it was 10 milliseconds. Now we're down to... oh no, it's failing hard. Apparently the sort is now taking 1 millisecond. So that went like nearly 10 times quicker. But it didn't really do the job properly. And I don't know why. Right, so we need to kind of say, hey, if I'm the first thread here. Alright, I know the problem. I know the problem right away. So the problem is that only one thread actually gets here, not all of them do get here, unfortunately. Wait a minute. Why did I need to know this? Yeah, we need to somehow get this source index back. That's what I'm trying to do. How do I get that? How do I get that back? So all the threads would know, would have the same best whatever, but yeah, you want to do a wave active min of this at the end. That's my problem. That's my problem. So at the end, I want to do the wave active min of that, and we'll get it back. Okay. I see it now. No, because... Right, so if it's me that found the best one, and if it was not me, I will clear mine back to E32 max because I don't know what is the best at the moment. And then we'll min it at the end. Okay, that should sort it out. Alright, let's try that. Right, still seeing something weird. But... okay. A lot of Vulkan use tabs on mobile, which is barely 1.2 right now. They invented profiles to aggregate features extensions, make it easier to target. Profiles. What do we have profiles? Because they brought stuff into core 1.2, right? I don't know what the profiles are. Because yeah, there are a bunch of features in that. Whereas DirectX 12 has more of like a, they have like a, essentially they have like a, they group the features together, but they don't tell you what the yeah, they group all the features together basically. So I guess that's what you're saying, they've done that now. I didn't know they've done that. What's happening with my silly sort function? That's not that great, but I just need it to work reasonably well. What have I done? Alright, they all seem to be the same value. We've seen this before. So the first value is different. The rest of them are like, I'm all this guy. Why? Right. So we do 32 threads to check over here. Grab the occluder. Get the max of that, yeah. Wave active min. The name's just a bit wrong. And that's the new best. So if some threads were getting here, but not all threads were getting here. Okay, not all threads will get into here. So realistically, you want this to be set back every time to nothing. And then only the best one. No, not every time. You kind of want to signal to every of a thread that something happened. So you want a boolean to say found. You kind of want it here where all threads are active. Found new best equals false. And then you signal found new best equal true here. And then you say, okay, if wave any, wave active any boolean. So if any of those found a new best, we want to clear it out, but only if, right? Only if we're not the one who set the best, who set the new best. So is me. Wait. And it's not me. Oh, for crying out loud, what have I done? No. Needs uniform vote. Have I not used this before? This is sad. Right, turns out we need a... I released a new version of the compiler yesterday. No. So, we need to add another capability. And needs to be compiled into the compiler. Damn these things. Uniform vote. Alright. Why? Missing before 1.3. No way. No way wave any is. Really? Non-uniform any. Right, what, is there another any then? They must have these in 1.2. Unless all these wave intrinsics came in. Alright, let's hop in the compiler. It's pretty simple to add. Spivvy link at the end, the final step. So non-uniform. So shuffle. Great. Have we got arithmetic in here? Yeah, group arithmetic. Ooh. Right. Maybe that is the right. That's the. I've named it wrong. 63. I think that's in the internal header. Right, I didn't put in that non-uniform. That's name's wrong. Okay, so I think I missed some wave intrinsics things. So we need vote as well. 62. Now let's make sure I've got all these ballot. Have I got a ballot? Broadcast. Let's check my spivvy gen. So non-uniform quad broadcast. That's a read thread for a quad. Read thread is a shuffle though, right? Because I've used that one. What about a quad? Broadcast. I wonder how this is different from a shuffle. But yeah, I don't think I've got a ballot at the moment. I haven't added one. Right, well the other ones like need. Clustered, I ain't got that either. Quad. I wonder when these were added. Yeah, I got that in there because I've used it before, but I guess the validation didn't pick up on it. Right, let's add the quad in as well. How annoying. 68. We probably want ballot at some point. 61's not there though. Where's that one? Exclusively, where's that one? I don't know. Alright. So you haven't gone all equal though either. Must be a boolean though. That's the same as any or all then, I guess. I don't know. Alright, so let's just plug those two in. Which one? Shuffle, sorry, vote and quad. So some new capabilities. Let's compile that. Get a new release build. Damn it. Why didn't I see this yesterday? Let's grab a new exe. Maybe I should add like wave ballot and that and do a patch. But I guess I don't know. Third party. It's thing invisible to the API. Right. Oh, they're intended profiles. Okay. Let's see now. Right, so we should have fixed that compile error. No. Oh, wait, we didn't even need to do that. I just misread the error. Result must be a Boolean scalar type. Yeah, I think we should put those things there. Ah, it's my Boolean types. I've buggered them up. I see now. Okay, so that's something to do in the abstract machine language then. Alright. So, wave, active any and all. This does some Boolean stuff. Oh no, it happens in SPIV. Yes, that'd be a signed in. So my booleans are signed 32-bit integers in shaders just because byte-sized types are not really supported. You can add support for them, but not widely supported. So I just use 32-bit ints. So basically we need to, I forgot we did to do the conversion now. But we would have done it for any and all, I think. Any was any. Here. Yeah, spivvy convert to Boolean. And then, yeah, we do the result type here like that. Right, let's bring these boys out. And then we do a select at the end. Excellent, this is what I want. All of this code. Yeah. So for that wave, active any and all, we kind of want these to be out on a separate thing now. So right, we'll just sort this out. Alright, so wave active any and all, select those boys there. So what we're looking at doing is, suppose I inline these. Right, so we've got the same. 5. Which means we need 4. 3. Yeah, subgroup. B1. Cool, so what goes in there? So if wave active any and all, it expects a Boolean that goes in, right? Yes, this will already be it. This needs to be turned into a Boolean using this logic here. Source operand. So we want operand 1, convert that. The data type. Good question. What is this data type meant to be? We can look at it like that. So the data type of the operand, put it in there. Then, so now that's a spivvy boolean, which is it's unsized. It's not got a defined size, so it could be anything. So that is now what we put in there as the input to the function. Now we get a result back. So realistically, we're going to get a different result back. So, right, let's get this right. Result operand. So rather than storing it in the typical return slot, we need to allocate a new spivvy ID which goes into temporarily. So that goes there for the first one. No, that's the type. It goes here. Taking place of the first operand, which is the return slot. The type is also... I lost the type. Where is it? Yeah, it's just spivvy type boolean. But it could be vectorized. So it's probably that then. Get the number of columns. The number of columns is return data type. And the return data type as well. Yeah, the return data type, which is actually just a boolean. We'll get that. Wait a minute. Shouldn't those be... Yeah, these wouldn't even work. These need to be deleted. You're just saying, basically saying if this is non-zero. And it's just a... yeah. So these are technically all wrong. Um, so these quad any, quad all, they're not vectorized ones. So I need to remove that from the compiler as well. We'll sort that out too, it's not too difficult. Okay, so they're not vectorized. This columns thing goes away. It's just Boolean. So you put that in the result. Operand, then you convert, get the storage class to select between 1 or 0, convert it back into an integer. Right, that should work. So we have to now quickly go and delete those other functions both internally in the compiler because they're intrinsics, and also in the header files. So this, I think, is in core. We've got a bunch of rules. So they're not vectorized. Not any or, I meant wave any. Yeah, these are not vectorized. Oh wait, no, maybe they are. You could do that, I guess. What does HLSL do? You could do... Well, they only do it for a Boolean anyway. Yeah, let's just remove the vector, because you could maybe do return a vector result back. But they need a Boolean vector to be returned back. Let's just remove it for now, because it didn't work anyway. Same with quad any. Then you need to go into the header files and remove that. So that should work now. So we should right, let's go into the maths. libhmaths. Probably just, no, it's not hmaths, is it? It's HTC intrinsics wave functions. So any Boolean and all this. So the vectorized stuff goes away. So all of those as well. It's always good to have less functions as well sometimes. Alright, let's give that a go. Yeah, I don't know, maybe they could have been useful. But it's just the easiest thing to do right now. If I need it in the future, I can always just add it. So, let's make a new release build thing. Go to the build. So I'm gonna grab that. Let's open up in a new tab. Then I also want to copy the intrinsics wave functions. Nice. Okay, so let's try and compile the compiler. Sorry, the game. The declaration does not exist in any what? What did I change in this then? Oh, wait a minute. So it's saying the compiler doesn't have an implementation for it, or I couldn't find one. Where is that? I didn't say Boolean types either, I think. No, this is bull. Um, Failed to link this. Declaration does not have any source file. It does though. Where would you be? Scalars. Oh, what is that? I think I ordered the wrong thing. Right, class scalars. Ah, right. I didn't order the fact that it works on the scalar operations only. Yeah, it's a bit confusing. That was a bit confusing, not gonna lie. Scalar ops only. No vector ops. Okay. That's what I needed. Right, compiles. Let's do a new release. Grab that. Alright. Oh, so we try that. Right, compiles now. Good, good, good. So the shaders now compile. Yeah, I guess I need to do a new release now. I guess it'll just be a hot fix, if you will. Let's get out HCC land. No. Anyway, that is okay. So now we've done this wave active any to say, wait, what are we trying to do? Yeah, we want to clear this out to max. So in this very terrible sort function, which is kind of which is slightly optimized now because if not, it's dead slow. We're saying here, if we were the thread, if any thread found a new best and it was not us, then clear the best occluder to the max value. So when we get here, after searching the whole array, which is very bad, but anyway, there we go. Get the smallest one with the best result, basically. There you go. Nice. That should work. Why is it jumping around so much? Still got a problem. There's still only the first so many. Right, source index is only that, which is bad. That only limits you to the first 32. So this would then need to do this instead. This plus that. That could have been a problem anyway. Yeah, base plus this. So it wasn't scanning the rest of the array. Okay. Now we're definitely getting more of the things show up. And it's definitely faster now, which is good. So I'm happy about that. We can up the number now. Shall we up it to 1000? We need to improve the occluder debug rendering because obviously those occluder shapes was just seeing it plain wrong. we should also remove the print code, I think. Disable that. Okay, so now we're doing 1,000 of them. But it says there's like 3,000 in total, so I guess... Right, let's improve the debug drawing, because that's just annoying. What am I doing wrong? Is it my half size that was wrong? And I thought that wrong. No, it's definitely not right. Alright, so let's re-go over this maths. So we're saying we take the best 32 occluders and copy them over here. Yes. Then we're saying debug draw the best 32. The best 32. So we get the center position. Divided by 128. Divided by 128. So actually get us a 0 to 1 value. Yeah, it's fine. Where is it? Yeah, divided by 128. Then times by 2 take 1. So that gets you minus 1 or 1. I'm a little bit skeptical on if this is actually minus 1 to 1. Yeah, it's looking like that way. I don't say anything more than 1 or minus or less than minus 1. So what about the half dims? Are they just too big? We saw that. They look like they are as big as the box. So am I putting it in the wrong space? Nope. Right, it's debug. This half dims. See what that's about. They're all the same size. Yeah, they shouldn't be negative values. They're negative in size. Yeah, I was expecting them to kind of be the same size, some of them. Yeah, because all the best ones were kind of... Yeah. So that's fine, it's just... Yeah, we didn't want it to be negative, actually. We just want it to be... Just realized that's probably wrong, isn't it? Yeah, don't convert to -1 to 1, that was silly. Okay, so I'm glad we fixed that now. Right, so there's our best occluders apparently. Best 32, but it's still jumping around, which I don't want it to be jumping around still. I think we've just got to have a bigger pool to sort through. See, the sort function is still taking like 2 milliseconds. I think we've just got to have a larger size. But I think as I increase this, we're going to need a better sort function, which I don't really want to invest time in. I think it picks 3,000 of them. No, but the biggest one should just go in there. So yeah, there's something wrong with the function. Big one should go in there first because it does the LODs at the top first. So what sizes are going in there? Again. Let's go back down to 256, where it's something sensible. What are the best sizes that we're seeing, right? So 16 by 16, what LOD is that? That's LOD 2? Yes, 16, 16. So we should be seeing some smaller ones as well. That's what I don't get. All of those were probably the same size. That was also a bit weird to me. So we see that back here. Just to debug that a bit. Why are all of those the same size? That's not right. Because we just debug printed out them here. Vulkan's so complicated, we should get into it. Yeah, it is a big thing to learn. Like, graphics programming in general is kind of big and complicated, and then you've just got Vulkan as well to kind of learn. It really does open up the door for a lot of like low-level stuff. But yeah, it is very complicated. Right, so these positions, they're all kind of the same, just with a bit different signs. Okay, but they are different. Whereas these are all the same. Not good. Because you just printed it out. Right, it's the first thread. What a bugger. Or maybe the print code is a bit wrong. Best occluder. They're all writing it in there, aren't they? Ah. Terrible. Terrible, terrible. You know where your best occluder is? So you need to store it in the temporary variable. For crying out loud. That's the reason why it's wrong. So you get the best occluder, store it locally. But you only really want the first thread to do this. Because and maybe that helps with the speed as well. Maybe that helps with the speed. So the first thread is like Yeah. I'll get the best occluder, store it locally. Then we're going to overwrite the best occluder with the one that we got in our current slot. And then we'll put in our current slot the best occluder. Right. That should also speed up. It might speed up the sort function too, which would kind of be nice. Ah, but it just made it work at all. Where's my occluders? No. Now we've got no occluders. What is going on? If we are the first thread. What is the best occluder index in this case then? Hey Mark8, how's it going? Rendering is not that complicated until you try to do it. Well, yeah, that's true. And do different things that not many people have done, basically. You're trying to sort of like... Yeah. If you follow like paths that people... Right, it's U32 Dan Max. What is going on? That means you didn't find the best one? Huh? Fishy, fishy, fishy. Something is a fishy. Yeah, it's fine. It's meant to be a local here. It's meant to be a local. Meant to be reset. Because we're trying to find for this slot the best one, and we just scan the rest of the array from the destination index. So it's fine to be reset. It's something up with this, I think. Get some programming juice. Why am I doing a wave active min here? That's done later, isn't it? Right, so each thread has a best occluder index. I guess maybe this is me, one might be failing, but no, it shouldn't do because it's a min. Oh, U32. Oh. Oh, that's gross. Right, so that was not good. Still though, that wouldn't have been the one causing the issue we've been having. This best occluder no longer has to be a thing that you have to set. Oh, what is this? That best occluder is going to be different. Right, this is also... Oh my days, this is painfully wrong. This is painfully bad. So best occluder here would be different across all the threads, right? Painful. Right, so how are we going to find the best? So your 32 threads checking in one go. Yeah, you might need to update the best occluder here, but you could do a read thread and read it from there. But yeah, no, you get the you can just update your best occluder. I think that's probably the issue. So you can just say best occluder. So you can update this. See, I don't know, this will probably make it slower. Yeah. Let's give that a go. This won't have to be here then. Let's see if that works. Okay. So we're seeing more of what I thought now. You've got an actual bigger occluders that are showing up, and then we've got the smaller ones. The smaller ones are the ones that are fighting, though, be the best. So I guess there's no... The problem with those ones... See, I want them to be the same every time. But the problem is we're doing closest to the center. And it's just picking those. But the problem is you have multiple nodes. So when you're sorting closest to the center, you've essentially got 6 sides of the cube, right? Which could have the same close, or even more. You can have probably 8 because of the corners. 8 possible sides with the same distance to the center. So in that case, the best one to win will probably be the lowest. The one with the lowest center position. Right, I guess you would do that last. And that could probably fix the final issue. So you would then select you would then do one more time. Which one? Probably need like an ISME 3 then, I guess. Well, there should only be one that's left at the end, so I don't think you need all this ISME stuff. So I think you can just do like no, closest. No, but if you can flatten it down with a length operation, then there's actually still multiple. No, there might not be. There might only be one. Which one is the smallest, I guess? Maybe that'll work. So then you probably do a length up on that. Which one is closest to the bottom left or whatever thing you use, right? And that'll bring it closer to the one corner. Closest or length from origin corner. And that might be better. looking for like a min. I don't think you need this sort of is less than. Do you need like a best then? Yeah, but these again, these are messed up too. Because these are not. You need to wave active min those as well. Or that one as well, innit? Damn it. It's just getting it correct is just a bit of a faff. Guess we'll just take that. Bit of a faff. Right, so that'll just be like a so if that is less than the best one, right? No, there's so much faff. Then so we should only have one that gets into here. So we can test that by printing out. And that's my hope, right? So if you're only getting one that goes into here, maybe that can simplify the code. I don't know. Figure that one out in a minute. So we should be seeing one yes. Wait a minute, what were we trying to... given a base. Given a base number, base source index, right. There should only be one per base. No, it says yes. Damn it, there's multiple. No. Why have multiple of these guys got here? Active min. Start at infinity. Infinity. Ah. So once you've found a new best, you kind of want to reset these to whatever they were up here. I should fix it, hopefully. Oh no, there's a bunch of yeses with the same. Wait, why are they incrementing by 1? That's not good. Doesn't make any sense. Why is that? Best occluder. $42, $41, $40. Oh no, that's fine. It should show up multiple times. That makes sense. What's the number that we can use? No, it doesn't actually. So you're seeing 39. His best is 39. Why is there so many that have 1? Oh no, it's all the threads will reach here, isn't it? Damn it. Of course it is. So we will need that sort of if statement we had before. Because there are... Yeah, I need to store it locally as well. I didn't do this. Two corners, mid, four. That's the wrong way around, isn't it? No, that's right, that's right. Okay, so the problem is we're allowing... So we're doing wave active min. So what happens if we didn't do the wave active min and only got one thread to come through here? You're going to read back the best result anyway. No, but you need to check amongst all the threads that we've just checked, isn't it? Which one is the small... Yeah. So we want to know which one is the one to actually do it. So that'll just be resolve all of this. Is me 0 and is me 1. And is me... Where's that yes thing we just deleted? So, if found need best, right, that should only print out once. Alright. Yeah, we only see it print out once now. But I don't know why we are seeing... We're not seeing it show up more than once. So we're seeing this sort of best occluder 0, best occluder 1. We should, in this loop where it's just scanned the whole thing, this should show up once. Because then if not, so that won't get called. And then is my, but then my best occluder index is just equal to 0, 1, 2, 3, 4, 5, 6. It didn't reorder it. Or did it? Oh, it's saying it didn't have to reorder it. Okay. Okay. So you take this occluder, and it's saying it didn't have to reorder it. When it does have to reorder it, it will... Okay. Right. Okay, so I think we've sorted that out now. That should be... Yeah, I've got a... So in my custom compiler, I've got a... Oh, it's still blinking. Damn it. So close. So in my custom compiler, I've got a... I got string support to the point where I can just print it out. I can just copy a string to a buffer. And effectively, I just copy it into a storage buffer where the element size is like a 4-byte integer. And so it's null terminated up to 4 bytes, basically aligned up to 4 bytes. And then after that comes all the information on it, basically just give it to printf, the other side. It's kind of a small version of printf because I've not supported all the arguments yet. But yeah. So I get printed from GPU. And I can also do this debug, all this debug shapes that you're seeing are all commanded from GPU as well. So we're able to say, hey, draw a bounding box, and it'll draw it. Yeah, it's pretty sweet. So it's a pretty nice experience to work on GPU now. Because the problem is, if you write GPU code, is you're missing all the best CPU stuff, right? So yeah, we've got printing here, we've got the ability, we've got ways to do global variables, we've got a way to do drawing shapes as well. 2D and 3D. That's quite nice. What have I done? What have I done? That's fair. Yeah, there's not many good resources on GPU programming, to be fair. Like, it's so complicated now. Oh my days, I just went through this big, dense bit of spheres and it made my frame rate drop. So, yeah, you don't see... I think there is printing in Vulkan in GLSL. It's an extension now. But yeah. You've written no engine ray tracer before. That's about it. Nice. That's cool. Did you do that sort of ray tracing in a weekend thing? Why is this thing not sorted then? Like, what's the problem? Is it just the fact that... right, so let's double check the code quick one more time. No, just kind of followed the amalgamation of tutorials. Awesome. Yeah. Right, so we find the destination slot, we're going to look for the best occluder. Got best occluder local. Got this sort of like best length to center and best length to origin corner in a way. Best occluder index. So we go over 16 threads at a time. Sorry, 30 threads at a time. You know, if we are, so we get our source index if we're still within the in the array of occluders. So we get the cube. Yes, we get the cubed volume of the occluder. Get the maximum between all the current threads that are sorting. Right, so it's 32. Get the maximum of all those 32. If we were the best, right, one of the best ones, right, because there could be multiple with this same value. We got that billion sets true. Now we say if this is best than the best occluder that we've got, and we carry on. So all threads will keep going through here, which is bad, because this is going to change that. We don't want that to happen. We don't want that to happen. So say if... So what we really want to do... Oh, for crying out loud. So you kind of want to know, am I the best? Am I the best one? And then the best one gets checked. Yeah, am I the best one between me and all of these guys? Then the best one gets checked. With the best occluder we've currently found. Because otherwise you're going to do a wave active min with guys that have not even qualified for the best. And that's a problem. Yeah, I think this is where the thing is breaking apart. So if we just store best occluder probably shouldn't exist anymore then. But the best occluder index should. So you're just trying to see, first of all, am I the best? So I think we'll copy paste this just for a second, because we're gonna like need 2 versions of it, I think. So we'll go, hey, am I the best one between the 16 threads for this metric, right? The squared volume, so cubed volume space. Yes, I am. And maybe some of my pals are. So us champions will go through. Then we're going to say, okay, calculate the length to the center. Yeah, do this wave active min thing. We can just move into there now. Am I the best? Am I the best? My pals. Yes, we are. Only the best survive out of the threads. Then we, as a final thing, we're like, okay, which one is just the closest to that corner? And actually, you're probably going to get multiple still if you've got a corner of a... Because it even works in 2D, right? If you got a corner that has the same length as that. So what we kind of want to say is breaking down to length op is probably not good. Instead, what we want to say is like probably do a wave active min. You could probably do a chain of wave active min, wave active min u32 in this case, dot x dot y. So if they're all equal to me, to my one, then I was clearly the best. So x first, followed by y, followed by z. So I was clearly the closest in that regard, I guess. But it means you can really have a really high up. That's alright. No, it's fine because we've sorted it closest to the center first. So this then, where's that yes thing? I think I deleted it. Get that back. Yeah, I want that yes thing. That's what I want. So we should only have one thing that pops into here per. Yeah, only one thread should pop into there then. Okay. Yeah, per one of these iterations. So after you know you are the one that's the best. What you want to do is set best occluder index to whatever your source index was, right? Say, hey, this one is the best one. The rest of the threads would be... So you kind of want to probably have like a... Or maybe you don't. You shouldn't have one thread in here at this point. Then from here you want to do the actual check with the best occluder. So you'll load the best occluder in. Which you wouldn't actually have. So you'll load that best occluder in here, I think. That only gets set later on. So you load in the best occluder. And now you'll do the comparison with the best occluder. So that'll be basically this code here. So we'll figure that one out still. So you've got your volume cubed thing. So that'll be this one. You've already got your center calculated as well. So just be this one here. Then you also already have your center to the problem is you don't have the one for the best occluder, so you just have to recalculate that quickly. Yeah, but it's not a length op. Actually, I just remembered. It's like a comparison op between. So it would just be a chain of occluder. If occluder dot center position dot x is less than best occluder dot center position dot x. Y z. Yes. Then we are the best. So I don't need to store anything along those lines anymore. So this can all go here. So that sounds more correct now. So, right. We are the, so only a single thread reaches here, and it is the best occluder out of the wave threads count. Now test it against our current best. Now we only can do this if this itself is actually set to something, right? So you literally just do like an if that is equal to U32 max, then actually this is an else statement. And then we plop that in there, right? So, best length to center, where did that come from? Right, that needs to be recalculated. Okay. So after you set this best index, only one thread did that, right? One thread only did that. So what you need to do is like a wave any, right? You kind of want to do it on like a local. Wait. I was the thread that did this. You probably need a boolean to say family best. And that probably needs to go more in this loop here. Wait, where did my for loop go? Wait, oh, it's it here. Huh? Is this in the wrong indentation? So it is 16 at a time. Oh yeah, no, that's right. Okay. Oh yeah, you already got there. Right, found new best. Yeah, so if we found new best and it's not us, we're gonna reset that back to U32 max, and then we'll fetch the best one back out within a wave active min. Maybe we could have stored a different thing, but that. Well, we could store a lane index and just read the lane out, and then that avoids this if statement. So you could say found best on thread index. That would be equal to U32 max. So that will just be a... So you set that, and you set this to whatever the thread index is, which would just be SV dispatch index.x. Then this one will go in here like that. So if any of those not equal to U32 max, so if any of them have found the best, so every thread isn't going to here, then we'll do this wave. We will then do a read lane, read thread U32 from the best. Wait. I think that's it. So yeah, value there, and then the thread to read from, like that. So yeah. So that avoids doing that silly copy that was trying to do is keep up to date as well. That was really annoying. I'm glad I was able to do that. So basically, I think we found ourselves the best. My concern is though, no, it should be fun. Right, set it for a spin. Ooh, what is here? Right, is that already, oh shoot. Right. It's good. Let's give that a spin. Right, so clearly bugged that up. Something's messed, and oh my days. Something is amiss, so we can debug with the printing. So we get multiple yeses. That is not a good. So we double check that again one more time. So, right. So it's best occluder index. That's reset. So we scan over every slot in the array we're trying to sort, and we simply just pick. Yeah, so we say, hey, we're going to find the best, or the best occluder for this slot, and not include the ones that we've already sorted. So we start from there, and then we take, we increment at 16 of them. Oh, sorry, 32 of them. Then we almost been a second pilot. It's been fun. Nice. So far the whole thing has been single pass. Has any reads the file once? No back tracing. Oh, okay. Yeah, it's a good way to learn, I guess, just making it simple. Because compilers can get quite big. Bare rest of the class is doing a rasterizer, and I'm the only one. Apparently first person did a ray tracer. Oh, okay. Interesting. Yeah, it's good to learn doing a rasterizer as well. Like just how OpenGL or Vulkan works under the hood. It's good to learn all that. Good to start there. So get the source index we're reading from. Found best on thread index. Okay, so we clear that out. So if we didn't go over the end of the occluders and we go into here. So you get the cubed volume of the occluder that we're testing against. What have I done? Yeah, active max. Of all the active threads who've not failed these branches before, get the max cubed area. if that's me, go through. So some threads will become inactive. Then we calculate the length to the center. Do the active min. If that's me, go through. Then take the occluder center position .x and take the min. So that's to like the lower corner, basically. And if that is me. Now apparently we've still got more. So of all the clusters, imagine these are all clusters and not spheres. How can the x, the minimum, how can that? I guess how can that be multiple of the same? Oh no, it isn't. Great, there's only one in there. That's good, that's good, that's good, that's good. Right, but some of them are best occluder index this. This is the issue we're encountering now. Some of them don't have a best for some reason. Which is not good. So why don't some of them have a best anymore? Or some of the first lanes, first threads, not have a best anymore. I guess that's the issue. So here we say if the best occluder, then we set our best to source index and say it's best found on us. And then if not, so that would have all, okay. So what we kind of want to do is have another thing here. Right, so have we got multiple of these, and then that one doesn't get set, so something wrong here or something. No, because only one of them actually get. Right, that's fine. We've guaranteed that's fine. So what about here? Do we see this where it actually sets the best variable? Right, we're seeing a few yeses still. But that still don't find. Something's definitely fishy here. I want to see, like, what did it say it found? It said it found a U32 max, you bugger. Something's really fishy there. So all of the threads should be going through here, right? There should be no inactive threads going through here. So I wonder what this is here. This integer as well. So it tries to read from that lane and it buggered it up. Apparently it's a U32 max. Did my did I bugger up the wave active Boolean thing? Did I mess that up? Let's make it equal. Well, you know, let's even just do this, right? Let's do true. False. Did I mess this up? Right, false doesn't print anything. True. Oh my days. No. Right, true does print something. False doesn't. Okay, so why? So any though. Ah, they're all reading from different threads, that's why. So in this case, so this should only be found on man, this was meant to be a simple sort function, but I guess it had to be made a bit fast. Maybe it would have been, I don't know. Maybe we could have got a general sort function and just used that, but anyway. That's cool. So we're moving a wave. So it needs to get the one. Yeah, this is just a bad idea. Why don't we just do it this way instead? So on this iteration, found new best. Found new best. And then your best will be equal to the min of active min. And that'll be the way, I think. So yeah, so if you if you hit this multiple times where you go through and say, hey, I found a new best one, that's still okay. No, the problem is we get multiple. Oh no, if you found a new best in this iteration between the 16, we'll then update that. Yeah, I think that's right. Let's move that here for a second. Wave active min found new best into there. Okay. Right, still a bit messed. Problem is you get in like it printing the same thing like tons of times because all the threads are in there. Okay, so it does this yes thing once, which is what we expect, right? Does it yes thing once, that's the new best, and then it will have a right. That's good. So my kind of concern is though is why is this such a low number many times? There's something a bit wrong with that, I think. So your best occluder index 3 here, then 2, then 1, then 0 again. Right, if you reuse the same one. Why is that? Because that's all the way. No. Oh, it's set in best occluder index. Shoot. Okay. Right, and update that. So that'll just be this here. Let me delete that line. Didn't update those two lines there. Okay, let's try that out. That should be what we need. Okay. It's still kind of flickering a bit. But we are getting one result. So I was hoping these would all be the same order between frames. But they're still not. So we're getting this show up once. And they're all getting set to an actual value. And they seem to be in the right order because they're kind of order, like because the size of the... So why the orders? So I think it's because the LODs that it's selecting, right? I think the LODs end up being so low that there's probably a better selection between the frames or something. So if we up this to 1024 now, or a slightly bigger number, maybe that will just fix it. So let's remove all the prints because I think it's going to be a bit of a... Okay, let's try that now. Yeah, I'm not sure if I can get it to be deterministic. That's annoying. I don't know what exactly is going wrong, but we're seeing one here, a big one, or if the big one's in the middle at least. So we've got some bigger occluders, or biggish, but kind of silly. These are correct size-wise. They do change. Right, I think I might take a 5-minute break, get a drink, and then we'll probably move on to rendering just rendering them, and we'll come back to this problem some other time. Because I think I just spent too long on trying to figure this issue, trying to make it so they get sorted okay. Something seems off still, but I just don't know. So then we'll just save it for another time, and we'll move on to rendering them, and then just trying to get this occlusion buffer rendered, and use that because it's not really a problem that they're not the same, because we only do this once when we construct the volume, but I'm constructing it every time we do it, because I just want to make sure that everything's deterministic basically when you construct a volume. But yeah, this shouldn't be flickering. This shouldn't be being have different results every time. Be good if they were always the same. But yeah, we'll just use these volumes now, render into the occlusion buffer, and then see how much it solves this problem. Does it remove all this? Does it stop us from over rendering basically? Because these are the occlusion volumes within this. So you'd have them sort of like kind of near the top and then going into the middle. So you should hopefully not render the ones behind, and in the middle, right? But you're not going to get the ones near the edge. Maybe some of them. We can increase the number of volumes. from 32 to 64, but yeah, we can just have a play about of it and see what makes the most sense. But yeah, I'll be back in like 5 minutes, so I'm just gonna go get a drink, and then we'll get those things rendering into the occlusion buffer. Yeah, enjoy the tunes. Right, hello everybody, welcome back. How we all doing? Oh, I turned my phone off so I can't see the chat. Let's bring that back. So we didn't quite manage to make this deterministic, but I think we're good enough. So let's get on to rendering. We've lost it still. There we go, we're back. Okay. I don't know, maybe See, these big ones always stay there, so maybe nah. Yeah, I don't know why that's... Anyway, we can always solve that in a future date. It's not really important anymore. So how are we going to render these occluders? So basically, for every volume instance, we want to take the list of occluders, which are in the volume, and we literally just want to ray trace against those. But we don't want to render them... we want to try and make sure we don't render too many pixels. Because the idea of this is we want it to be really cheap, really fast, and to save us time in the end, where we can render less spheres and less clusters, and maybe even less volumes, right? Less instances if one volume completely covers another one, right? So, or if a group of volumes cover up another volume, right? So, um, so how are we going to do this? So we've got a bunch of volume instances. We need to go over all the volume instances and then probably yes, I think we just do it in a single shader because we know this is 32. So I think what we can do is just make a new shader. Love making me a new shader. So it's basically a ray tracer. So we want to do another ray tracer. We ray trace a so it's not going to be tiled, tile binned. It's dead simple. Basically, you got a screen, you got a volume in it, and this has a bunch of occluders in there which we've made, right? So all we're going to do is basically we go for every thread group is going to get a volume instance. We'll go over all of the instances, and then we will get an 8x8 set of pixels that we're going to try and draw, and we'll ray trace against each one of the pixels will ray trace against the occluder, and then it'll go to the next one and ray trace against all of those. So I think we're not going to, and the beauty of doing it that way would then mean it would then mean so the biggest problem is you want to avoid writing to the same you want to avoid writing to the same pixels in a texture than another thread at the same time. Because otherwise there'll have to be some cache synchronization. So the beautiful thing is all of these guys will be in the sort of the same area. Maybe they'll overlap a bit, but that should be okay. I guess the problem becomes if you have multiple volumes overlapping in the same space, then maybe it doesn't really fix that problem. But this should be less cache synchronization, I guess. I don't know, maybe. But let's just try it this way and just see how well we do. So do an 8x8. Did I copy this? I think I did. No, I didn't. Let's copy it. Oh, this is the BVH one. All right, here we go. So sphere ray tracer, sorry, occlusion, occluders ray tracer. Okay, so it's just gonna be an 8x8. We probably want to have our own one of these guys, so let's go and do that quick. Occluder ray tracer. So we're literally just going to take in all of the volume instances as an array. And then we're going to also have all of the... wait, that's all we need? Then we need the output. We need the output occlusion... occlusion buffer. Right, that's an old version. But I think this version is better. This works per cluster. It doesn't try and do it at the sphere level, which is not that good. So we need an occlusion MIP space ID. We'll also need a way to clear. So this is where we'll be writing to. It'll be a MIP chain. So this means that we'll have one full resolution buffer, and it just records a depth. So each pixel records a depth of where the furthest, or the closest thing is that occludes the stuff behind it. Per pixel, obviously. But we'll do it as a MIP chain. So there'll be a low resolution version of this and a low resolution version of that. So we do this for two reasons. One, when we populate this buffer, if you have a massive occluder, right? Here's the occluder. It should really be in 3D, but you know, this is the occluder, right? Blah, blah, blah. So basically we were going to ray trace against all of this. But as I said, we want to reduce the number of pixels that we're writing. So the way we do that is we actually write to a lower MIP, where the pixels end up being 8 by 8-ish. So it probably writes between 4 to 8 pixels. Because we're just going to half it, basically. So we'll write between 4 to 8 pixels to the screen, which would be the occlusion and for that volume, basically. So we need to select the appropriate MIP and write to that. And the second reason why we do it is for the other way around. When we want to check occlusion, right? We're trying to render this cluster, which is filled with spheres. What we want to do is say, hey, is this cluster definitely not occluded? And then, so we'll have a bunch of, you know, you got the size of this thing. We only really want to check one pixel to know if we're occluded or not. You could check multiple, but one is probably the best. So we do that by selecting the appropriate MIP, where, so we'll get the bounding box and we'll select the pixel, which, you want to select the appropriate MIP and pixel. Yeah. But maybe that's where my code was wrong before. Anyway, we'll see about that. Just remembering things. But anyway, we can see this. So here we go. So that's all we really need. Is those two things there, which is super nice. So what I want to do is fetch the. Alright. So I'm going to fetch the volume instance. And then fetch. Oh, we need the volumes as well. Derp. Of course. We need the volumes. And we probably need the clusters as well. Why do you need the cluster? No, you just need the occluders within the. Hey, Legend of June. Thank you. How you doing? Welcome to the stream. So you just need the occluders from the volume. And you're just going to try and render those. So volume equal, yeah, so on these two lines of code. All right, so basically you get this based on, so the volume instance index, this is going to be equal to the group index, right? So not any one of these 8 threads, right? These 8 threads belong to the group size, but we want the index of the group. Like that. So we'll launch all those, be quite good. And then what we're going to do is get the volume instance in the volume. And now we're going to go over all of the occluders. is less than volume dot occluders count. Occluder plus equal 1. So now you get your occluder out. I think we'll just do occluder equal volume dot occluders occluder index. All right. So now we've got this occluder. We need to move it from local space into view space. So the way we do that, we get view from local, view from world. Now, what did that debugging code from earlier? But excuse me, we kind of want something like this. So I get this code here, and it doesn't really need to be enabled anymore. So let's go back. Right, here we go. So we'll plop that in there like that. This is how we turn it into sine norm space. So this will be -1 to 1 of inside the volume. Then we need to get the transform. So what we need to do is get the view from world, and then we'll get the volume instance world from local, and that will produce us a view from local. I want to see if I should really pre-compute this, because that could save us doing it too many times, because we do it already in some other places. But yeah, anyway, so we are now going to get our okay, so what I need to do is a OOBB, or is an AABB ray trace function. I need to find it and then move it somewhere. It's just somewhere in this file. Well, maybe not. This is a bordered one. Maybe we need to copy this in ABB verse ray. Yeah, it's all bordered. Alright. So what we're going to do is copy this, and we'll simplify. ABB min-max. Wait, did I do an OOBB? An OBB? Wait, why is there 2 of these guys? Oh, this is commented out. Alright. Let me delete this code. It shouldn't be in here. Right, here's the one. Alright. So I think I want this. But I want it as a non-bordered one. This one is for our debug drawing stuff, basically. So if we find where we just were, I'm gonna do the silly thing and just, you know, this code is actually quite messy because I'm trying to find the graphical art style that we want to use. So I'm just basically getting stuff done as quick as possible. So the tidy up stage will come. Like the rest of the code base already has that. It's just this code, this part of the code is just like so 4,000 lines in this file and just messy. That's okay. ABB versus ray. So we don't want this border thickness. So anything to do with this border thickness is going to get nuked. So we'll get like a min-max back, but we only want a min. So a near. T near should be that's the normal. Yeah. So we want the normal back. I don't really need the normal, but yeah, we'll just use that. Oh shoot, what did I just do? I went and jumped to the other place of the code, damn it. Right. So we can delete all this, and we just want... Yeah, that's what we want. So we need ray origin, ray direction, and ABB half dim. So we need to translate into the center of the... where the origin is the middle of the box. That's what we need to do. So how do we do that? So we need our view ray. That's number one. Right, it's fine when we did this with the border one. So we need to go the other way around. Something like that I need. Hit. No. Still, that's the wrong one. That's not the OOBB one. Yeah, debug draw OOBB. So let's take this, and we'll remember what we need to do. So instead of view from local, we need local from view, because we're going into the local space, and we're moving our rays. Okay. So we kind of just want to make that once anyway. So let's make our local from view, which is the inverse. Oh no, I'm disappearing. Thank you, Rosmusco. That went quick. I was keeping an eye on it. Thank you. How's it going, Rosmusco? It's the legendary Rosmusco. Yeah, it's really cool seeing your VR stuff in the Discord. Yeah, it's not in a big room either. I'm just sort of jogging across this yeah, tiny room. So yeah, good fun. View from local. So we need array origin in view space, which is just 0. Yes, I just did that. And then ray direction. We need one of those that I made earlier. So we're going to get that. Here's one I made earlier. So we get those from the globals, and voila. So the coordinate, we need to get the bounding box. Wait a minute. We don't know where we're pointing to just yet. We only know that per occluder. We need to get the screen bounds of the occluder, I think. Yeah, I think it's from the occluder. You need to implement collision detection yourself. Oh no. Yeah, 3D collisions. Yeah, but yeah, I remember doing it before, but I did SAT, basic SAT. I didn't do the GJK thing. But I'm sure you got this, Rosmusco. You know, you've got good math skills. I wrote like a custom debug viewing thing where I can drag two shapes and sort of intersect them and move them into the right positions and try and find all those edge cases, you know. Yeah. I think I did my own capsule maps. Capsule versus capsule, or capsule versus hoop, I think it was. And I think it was okay, except there was really one weird edge case I couldn't solve. I was like, no. Would you do like a convex convex hole type of collision detection? Or how would you do it? Or would you do other primitives instead? So we kind of need to get the screen space. It's kind of annoying. Actually, I didn't think about this. We'll need to get it anyway. So we need to get the screen space bounding box of this occluder. So we can figure out how to write it into the texture and all of this. So yeah, let's go and grab all the stuff for that. So we did this in the cluster code. So prepare clusters for whatever. This one. So in here, we do a bunch of stuff. What am I looking for though? Yeah, I want to get the rough box, don't I? So if I move it, damn it. It's kind of all of this code here. Hmm. So you kind of just need it in local space, and I can do the rest, I think. Yeah, I should make this, reusable. Maybe. You kind of want to get the outer bounding box of a... Alright, what are we trying to do? Of a center position and a... Yeah, let's make this function. I know where I want to stick it. It's basically like screen, outer screen bounds, so ABB 3D 2, okay, of ABB 3D, something like that. So you're taking like a transform 3D view from local. You then also take in the local space center position local space, and then the half dims local space. So then what you'd return is that those pixel coordinates. Do we probably want those in some kind of projector screen space, bottom left, bottom max. You might want them as float, I guess. Probably always want them as integers. There's paper that looks tempting. Differentiable collision detection for a set of convex primitives. Oh, a set of primitives. Right. Hmm. Fair play, I'm gonna take a look. This paper doesn't look half bad. Maybe, or maybe not. Maths. Right, it's got some good pictures, and it's not that long. Interesting. Thank you. I'll take a look at that. That's probably a good read. Not that I'll probably need it, but it's kind of interesting to learn stuff. Yeah, I need to drop the things in here. Probably better off returning a. This was good debugging stuff, though, wasn't it? There's an impulse implementation if it's written in Julia. Okay. Yes, that maths language. Lovely. 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 Yeah, I've seen that. You know, people do some stuff in that. You know, there's a UTF-8 proc library. You know, that sort of single header sort of UTF-8 thing. But it's written for the Julia language. And this is quite handy if you're doing UTF-8 text and stuff, because it gives you all the data tables and that. But yes, that's not really. I think I've seen the language a bit. Right. Unorm, snorm. There's your snorm. So I think I need to actually move that back out. Crap. Where am I going with this? There. Alright. Yeah. Where's my half dims at? Good question. Half dims, where are you? Right. I already made it. Fantastic. Okay, so now it's got to tweak all these buggers. Half dims, local space. Okay, this we're going to disable. It'd be great if we could enable that somehow. Again. It's good debugging code. Right, so anything to do with the word cluster, we're going to just look at that. Cluster position in view space. That's now center position in view space. Oh yeah. Wait. Did I was just searching for cluster still. Let me just double check that. Because I overran too many things there. Not a good. What is this? A shader. We're currently writing a occlusion buffer, so we can basically say, hey, we got this sort of cluster here. and it's got some occluders in there, right? And we're trying to sort of render these occluders, which are kind of like cuboid shape as well. So we're trying to render these occluders to the screen right now. And when we have a buffer filled with a rough idea of a rough depth buffer, we can use that to see if to occlude objects to be rendered, basically. Someday you have to build a big data processing software. Okay. Right, so anything else with the word cluster in it? We have to correct center position, local space. Right. Yep. Okay, so nothing else with the word cluster in it. Right, so I think that's everything changed. So now we just need to return the bounds. So the bounds is going to be a times 4, bottom left, x, y, then right, and then we'll just unpack it and use it properly the other way. So what I want to do is I want to put this in the right place. Wait, the other one comes after. So it can just stay there. Good. So this thing, I need to... Right, it's called bounds now. Screen bounds. So we had like a bottom left and a thing like this, right? So height in pixels is screen bounds dot y. It's the bottom, top is w. We keep going. You know what? Let's just do the same thing. Bottom left equals screen bounds dot xy, top right dot zw. There we go. Far better. So half dims local space y, you know work. Oh, because that is a dot x dot y dot z. Screen bounds. Excellent. So we're passing in times 3s of that. Nice one. There's no epsilon anymore. Whoops. Let's grab that. Pop that there. Why doesn't that work? Oh, t. We're going to return tn. T near. Coordinate. Excellent. So we're back into here now. So we now want to use that lovely function we just made. It's called outer screen bounds of ABB3D. So here we can literally just take these center positions and these half dims, right? And the view from local, and we can now get the screen bounds out. Incredible. So we can now use this information here to figure out our bounds, basically. So what we want to do is we want... So if our screen bounds is less than 4, we want to skip it. So we want to get the sort of probably like... You probably want to get the largest edge or the smallest edge? Largest edge. Did you try to implement a research paper from computer graphics or something? No. I guess some of this stuff has been papers, but yeah. I've just sort of picked up on stuff and I'm thinking of what's the best solution for the problems I'm trying to solve for this specific project, really. So we're trying to render a 3D volume of spheres. That's the basic idea. 3D volume of spheres, 128 cubed. And we're trying to render those, as many of those possible. So this is like 2 million spheres per instance. And I'm trying to see how many of these we can render. So we're trying some optimization techniques out, like an occlusion buffer, to see if we can render a cheap set of occlusion volumes and seeing if we can cull clusters that don't need to be rendered, basically, and seeing how that goes. If not, we're going to try a different thing out. But yeah, this is one of the techniques we're trying. So you get the screen bounds of the box, and that will be... so the problem is if you have a thing with a short edge, like that, say you have a very wide and short box in screen space, you kind of want to get rid of the occluder. So if the occluder is, yeah, same problem as this 8x8, you're only doing 8x8 pixels. So you kind of want to say if the smallest edge is less than... yeah, I haven't thought about this actually. Maybe not smallest edge. See, this morph, it can happen. This can happen. But I guess this means that the thing is very morphed. And in that case, we might not render it. Like, we want it to have a kind of a... yeah, so... why don't we scale... so we kind of want to say if the screen bounds is... you get the biggest edge, if the biggest width... sorry, biggest width or height is more than 8, we want to divide it by 2 until we make it less than 8. Right? So you want to figure out how many times you need to divide it by 2 to get it less than 8. So you get your sort of like biggest edge. Biggest dim, so max S32, screen bounds dot W Z, no, yeah, Z. So Z will mean the bounds is basically a bounding box where it's got the min and max in the coordinates. So it's max x take min x. Not confusing at all. Max y take min y. So yeah, get the biggest width or height. Maybe it's better if we just did oh, whatever, anyway. Maybe it's better to do this width. So if the biggest dim, yes, you want to work out how many times you have to divide to get this to 8. So if it's like 16. Then you want it to be 2, right? So you probably want to just call it t for a second. You want to say biggest dim divided by 8. So that'll give you 2. So you probably want to do like a rounded up divide. So if you get like 15, it has to divide it at least once. Wait a minute. No, that's not right still. Yeah, so if you do, so you got 15. Yeah, maybe it is that, and take 1, I think. So you'd do, so if you got 15, right, divided by 2. Sorry. 15 divided by 8. So I guess you just, it'll truncate down to 1. Sorry, it will round up to 2 actually, and then we'll take the 1. Yes, that's how many times we need to divide. So if it's like 20, 25 across the biggest dim, that'll be divided by 8, and then that'll actually round up, wouldn't it? To 4, take 1, then it'll be 3. So we did 25 divided by 3. Sorry, divided by 2 3 times, which would be 6. 4.1. But they never did 24. Then that'll be take 1. Then that'll be 8 exactly. Yes, that'll be 8 exactly. We divided by 4, wouldn't it? It'll be 6, sorry. What? Yes, so divide by 24 divided by 8. So I'll give you 3, take 1. Oh, it's yeah, okay, 24 divided by 4. 6. So it'll be 6 pixels. What am I doing wrong here? Right, so problem is I did the take 1, I think. Right, it's how many times am I dividing by 2? Right. Maybe it's log. I need to use log 2 then, isn't it? That's what I'm thinking about. No. Maybe not. That's powers of 2. Uh, 24 So how many times 8 fits into 24? Maybe just divide it by 3. Yeah, so if I just divide it by 3, then that'll be 8 exactly. Then 25 divided by 8. So what do I do in this case? Do I round it down by... Do I divide 25 by 3 still? No, because that'll be above 8. So we have to do a... So that'll round up. So 25 would round up to the nearest one, which make it 4. So it'd be 25 divided by 4. And then make it... Oh, my days. Okay. So I think we want to do then... we divide the screen bounds... So could we use this to select the MIP, the MIPS then? Because that's how big it is on the screen, and this is how many times 8 fits into there. So, like if it fits 2 of them, you're selecting the lower MIP maybe. Yes, I think this is the MIP. This should be how we calculate the MIP level to write to. And then we simply divide the screen bounds. Divide equal. So So this can be 0. So ZW, okay. So my thinking is though, that should be fine. If we, yeah. Okay. Just how many times we divide. Yeah. So that should be the screen bounds at that MIP we want to write to. So we've now got kind of like 8 pixels. So we should recalculate the width and height. And we've now got the screen. You also want screen dims at MIP. So this would be divide with a scalar, and that's probably a, wait, what is this? E32, okay. With a scalar of E32. The scalar is MIP plus 1. Then we can cast that. Okay, so I guess it's our redirection in view space. So now we've selected the appropriate MIP level to write to, and we're able to figure out our pixel now. Coordinate. So the coordinate we're writing to is if... So coordinate, which one are we gonna use on the screen? So we first want to say if the SV, it's not dispatch index, it's the local, right? So from 0 to 7 inclusively. If that is less than width and this is less than height, the y is less than height, this will mean we are within the, so maybe the screen bounds is only like a 4x4. It's somewhere between a 4x4 and an 8x8, right? And then we can, so I guess I can put a comment there, right? Width and height is between 4 to 8. Now we also want to say, oh, by the way, if width is less than, you know, okay, I can just put it here. Less than 4? Oh, no, we'll do that. Shoot. We want to have probably at least maybe 2 pixels. The largest dimension is between. Let's try that. It's better. So I guess I'm going to say if either of these is less than 2, then we have a problem. We will just continue on and look at the next occluder because it's just been stretched so bad that it's just not worth using or something like that. Yeah. So if we are a pixel that can be rendered, what is next to do here? So coordinate, we need to calculate coordinate. So coordinate, I think that's a right. So the coordinate on the screen is then going to be this sort of local x added onto screen bounds dot x plus that. Do the same for the y. Oh. Okay. Coordinate goes into there. Screen names at MIP. Cool. Field of view, nice. Now we do the reverse ABB, which we made earlier. No border thickness. We've got this half dims thing in view space. No. Oh, that's the old one. Whoops. All right. Yeah, that was for the, I copied that from Axis Line Bounding Box debug drawing code. In this one is copied from the orientate bounding box. So what we need is the inverse of that. Yep. We need the ray origin in local space, which we could pre-compute up here. And then we need the, we also need that in the, sorry, the ray direction as well. Ah, shoot, I did the wrong one. Ray direction in local space. So where's the ray view? Right, these boys. So all I need now is the, wait a minute, that needs to be a subtraction probably. I need to subtract because we need to have we need to go towards the center position of the occluder in local space. That needs to be passed in there. The ray needs to be relative from there. But yeah, that's correct. Okay, so this will determine if we've got a hit. Then if we've got a hit, we're going to write out a pixel. So how do we write out a pixel? So how we do that, let's just do this quickly. U chord let's just set that all up. F32 crying out loud. F32 times 2 cast. Right. So we want to say we've got a hit. So if that is greater than 0. Because I think it sets it to negative. Yeah, it says it's sets it to negative if it fails. So if we have a positive T along the ray, we are then going to write out a hit. So effectively we're going to use atomic we're going to use some atomic mins. So we want to get a read-write texel address for a float 32 shoot. You can't do an atomic min. That's fine. You can do an atomic min on a U32 and it's still the same as a float. You just got to reinterpret the thing. So you get your hit depth, which is hits.y. Oh, sorry, .x. So depth, right? So we need to convert that bits to, or bits from float 32. That's what I want. So we convert it to U32 from a float 32 just to reinterpret cast. And we're going to store that in the occlusion map thing, occlusion buffer. So there's a base MIP thing. Let's just get the right texture. So we get the texture here by saying occlusion texture. So essentially we use bindless resources. So with bindless resources, basically you have an array of descriptors that all sit next to each other. So a descriptor is uploaded from CPU to GPU. So when you create your textures, you upload your textures into an array, right? So we use bindless, so we just have indices. So inside one of these descriptors is basically like a pointer to where the pixel data is. So this is kind of all opaque, and it's different between implementations. You don't really know what specifically goes in here, but basically there's a pointer to where the pixel data starts. There's some other information like the width and the height of the texture, and probably like how many array slices it has, how many MIP levels it has, right, and all this. So that's just all stored in that descriptor. So basically we have so you can't write to a specific MIP. You have to make a texture view or an image view in Vulkan's case. So we basically we make each descriptor be a different MIP. MIP 0, 1, 2, 3, right? So you can only sample from different MIPs. You cannot load you can load, but you can't store. Just the way it is. Don't know why. A bit silly. So yeah, we put them one after the other. So we take the base index into the descriptors. We'll add the MIP level. So here's the MIP. And then we convert that into a texture 2D. So we pull this, my compiler pulls it out of the descriptors as soon as you use it. But this is just an integer, this thing. So you can write these into buffers and whatever. So it's really great. So we've got our occlusion texture. We're going to get the address of that texel at that MIP. Then we're going to do an atomic store. Sorry, atomic min U32. You'll see. Crap. Great. Atomics. Yeah. Min U32. Right. You'll see that there is no atomic min float. There just isn't. I think there are some extensions for it, but they're not well supported. But atomic min U32 will be the same bit pattern as a float. So that ought to be good enough. So we're going to atomic min that into there. So this will solve the problem when you have multiple threads trying to write to the same pixel. Yeah, but we should hopefully not have too much overdraw. That's the hope. So let's delete all this code, which came from the other shader. And this is basically the shader. We just need to double check it, get it compiling. We need to, yeah, things. We need to then dispatch it CPU side. But we should be able to give this a go and then view the data in Renderdoc maybe, but I don't really trust Renderdoc anymore because I think I've messed it up somehow. I think it's me personally that's messed it up. Alright, so let's double check the logic, then we'll dispatch it. So, right, we get our group index is our volume instance. Get our volume instances, sorry, get our volume instance out, get our volume. We calculate the view from local and local from view. Then we, what is that? Yeah. Ray origin in view space, move into local space. Go over all the occluders within the volume. Then calculate the local space, center position, and half dims. Calculate the screen bounding box. Of that, the outer screen bounding box. So if you have a ABB like this in local space, right? This is in view space. This is not axis aligned, but in local space it is. You'll get the outer box like that, right? So we might have pixels that are outside the box, right? So maybe we should say it's less than 4. I don't know. 2 is probably alright. 2 might be enough. You might get something drawn, maybe. Yeah. So get the screen bounds. Calculate the width, then the height, get the biggest dimension, figure out what MIP we're at, we want to write at, adjust the screen bounds to that MIP, adjust the width and height to that MIP, screen dims at MIP. Cool. Then we that might be a bit off. We've got to figure that out. Yeah, the width and height is too small. That's right. The largest dimension is between 4 and 8. If we're inside the width and height, we calculate the screen bound. So there might be some. This is an 8 by 8. There might be some threads that are not in here. That's fine. So we get the coordinate, which is the local index plus the screen bounds. We do our array verse, or we calculate our array direction. Now we know which coordinate we're at on the screen. To convert that into local space, then what is this? This can go. Wait. Yeah, what is that doing there? That's wrong. Cool. We get the depth value. If the depth is not negative, meaning we hit it, we get the occlusion texture. At that coordinate, we write the depth, but we min it with an atomic min. Great. Yeah. Let's give that a go. So that should work. We should then be able to debug. The problem is that's only going to rasterize. That's going to rasterize on different MIPs. We're not going to see it on every MIP level, unfortunately. So what we should do is probably view it in RenderDoc, or do the second pass, which downsamples it and upsamples it, which I've already written that code before in the past. We'll just see how it looks. Let's plug it all in. So this occluder ray tracer needs to go kind of at the start. I don't know. So why are these still running? Prepare clusters. All right, before this prepare clusters, we need to run this. So we need to find that prepare clusters for render. We do something kind of right, so volume instances and then occlusion. Let's get this in the right place. Yeah, okay, just need the occlusion base MIP index like that. Then we need the synchronization code. So we're going to read right to that MIP thing there. Okay, very nice. All right, how many of these we're doing? Based on the number of volume instances that we've uploaded to the GPU that frame. Divide by 32. No. 1 per group. Yeah. So we launch that many groups. So 1 group per volume instance. Then that gets an 8x8 region on an 8x8 region of pixels to possibly render. And then it goes over all the occluders, figure out what the occluders are on the screen, render that 8x8, and atomic minute to the screen. So that should be. I don't know why I've not done BC here. I don't know why I kept doing that. It's just silly. Anyway, so yeah, this could probably just be a macro anyway, which just does that automatically. But anyway, okay. So we checked over the code. I think it's fine, but you know, the AMD drivers kind of like to die hard if I do something wrong. So if the stream crashes, I'll be right back. Let's go. Right, so we're rendering now. This sort occluders is 5 mil on milliseconds, right? The occluders ray tracer is 0.5 milliseconds, and I'm not even it's pretty consistent though. That's good. But the, you know, I've not got many. So yeah, I was hoping for it to be far less at the moment, but I guess we're only doing, yeah. The problem is this is not using all the compute units probably. because we're only doing 2 waves that get launched. So we're not occupying all the compute units, so maybe that's okay. So should we take a look at the what Renadoc thinks it is? And then if not, we can just try and debug it by ourselves. So let's launch Renadoc. Let's go to the screen. Let's do that. So load up this boy. There'll be a pass where we do the render. So we should only have 1 group. So it's actually going to be quite hard to find. Oh boy. Right, that volume. Alright, this thing needs to be cleared. I forgot to do that. Clear. Occlusion clear. What was this thing doing? So it's just storing U32 max. We've got a function for that. Alright. So what we actually need to do first is a clear texture. Texture clear. Yeah, I already got this thing for it. It's pretty good. You just pass in your... Oh, it doesn't clear every MIP. Maybe that was the problem. Yeah, maybe that's why I did it. Okay, we'll copy this shader too. I probably want to... Alright, where's that shader? Just plop it here. You know, maybe we'll just run that same shader. I won't bother changing it because I think I don't want this to be the solution in the end. I think I want to pre-populate with the depth from the previous frame. So maybe if we just run this here, maybe that'll be fine. All right, let's run that. All right, let's get rid of this fella. All right, so the clear's happening now, right? Yeah, occlusion clears. It clears all the levels. Okay. So if we run that again, hopefully Renadoc picks it up because we've had some problems in the... it could be me, not gonna lie. Right. View the texture slice. Oh, sorry, texture viewer thing. And we want to find the... Alright, somewhere in here. Occupation map. Occlusion texture. Excellent. Wait. Oh, these are the clears. Clear, 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 clear. Clear. Okay. Occlusion texture. That's the dispatch, I think. That's the draw. Yes. So this is our guy. So what value we're looking to see? Probably U32 max, like all the way over here. Nowadays. Damn it, we're gonna have to just go into... Oh, what have you done, Rust? You've ruined me. I guess these guys ruined me too. Right. So we should be seeing something. We're not seeing anything being written to, which is weird. So what I'm going to do instead is just... We can just render the final buffer instead and just see what we land on. I don't know if I can trust render doc anymore. I think I've messed something up. So when we do our final render on the screen, we could probably debug draw something so we know where we are. Where's those debug draws that we disabled? That was in make persistent, I think. Yes. So let's enable these again. Yeah, I want to just see the so we kind of know what way to look. At least. I don't know. We probably just want to see the box. Hard. Yeah, we kind of just want this. Maybe in the prepare clusters for render. Stuff. At LOD, we could probably just do something. We've got view from local, right? Why don't we just say if cluster index equals 0. Render view from local, and that just puts the whole box up. Alright, let's try that out. Oh, that didn't show up. I think it's never equal to 0, that's probably why. Let's say LOD. I don't know. Should be. Alright, we should be back. Hopefully, yes, it didn't end. Right, back. Right, I know what the problem is. We didn't do a safeguard, it was outside the bounds of the, when we wrote the occlusion texture, we didn't put a safeguard to save, we're outside the bounds of the, outside the bounds. Occluders, ray trace. Yeah. So we didn't do the thing where we say, so this allows us to go outside the screen entirely. Not good. So we need another if statement. If coordinate dot x is less than the screen dims and the screen dims.y. Then do this. I'm pretty sure that's the problem because there's no other sort of writes we've done, so it must be this line of code here. That's the problem. So yeah, that'll fix it. It wasn't because we did that debug draw stuff, I'm pretty sure. Right, let's give that a go. Yeah, we can go outside the bounds, that's fine. Okay, so basically we've got this box now, which is great. So we can tell that's going to still be drawn when we're going to debug view this texture. So I'm going to go close and see and far away as well. I'll be able to see it hopefully appear on the texture. So that's in the ray tracer, I think. Which one? That's a good point. Oh, why did I do that? Oh, it's thinking I'm there. Okay. Ray tracer. Did I still call it a sphere ray tracer? That's the BVH one, which I'm looking forward to doing again sometime. Right. This one. Sphere ray tracer tiled. Okay, so is that one? Sphere ray tracer tiled. Okay, just got one of those, which is good. I've not. Okay, so in here, well, yeah, in here, let's write a pixel out of the end. And it's going to be like, what do I want to write? I want to sample from that occlusion. It's a bit of a bugger to look at. Got to pass it in. I could just figure out what this is and it doesn't change. So I could just hard code it for a minute. Yeah, let's just figure out that. So printf resource index. So let's figure out the index it is in the descriptors, and we'll nip that. .48. So we'll just hard code 48 into here. So mip one of these. Right, good. So 48 plus mip level. So I guess we'll just look at the mip 0. We should also probably get it to print if we do ever write to mip 0 in the terminal, but let's just start here. This will be full res, pretty sure. Occlusion texture. Occlusion texture ID width height. Okay, good. So, all right, happy about that. So we should be able to read from this, get the pixel. So depth equals bits to a U32, and we're gonna load from a texture 2D of U32. So put that in there. I'm gonna load from ucoord, and then we're going to Yes. So this is the depth. I just want to render that out. So I guess we can just say color red probably. So red, blue, red, green, blue, alpha. Sort out all this stuff and fire away. So we should be able to debug the texture now on the screen. All right. So it's just black at the moment. If I go further away, do we start seeing stuff appear? So they've got to be around 8 pixels in size, maybe. So I guess we should use the debug drawing code that we've got, because this can really help us see what's going on with our variables, basically. So why don't we start there? So we've got this here, which is great. Let's just leave that there, and we can try and get it to work. So in this occluder's ray tracer, we've got the screen bounds. So we do have a draw 2D API, which allows us to draw an axis line bounding box. Yeah, so center position, half dims. Oh, it's also got a min max one. Pass me go. So the min. Why did I do floating point? I don't know. Screen bounds.xy. Yeah, that'd be fun. And then dot ZW. Depth. Let's just do 1. Doesn't matter. Border thickness infinity. Wait. No, we'll do like 1 pixel. Color, we'll do like probably a white, I guess. Yeah. So that should debug draw the screen bounds, and let's just see these volumes on the screen at least. Sorry, the occlusion volumes. Right, clearly that's dead slow. I don't know if that just tanked some of the stream there. That's probably right. Okay, that's good. That's a lot of shapes apparently. Too much for this to handle. Let's just save your occluder index equals 0, and then let's like just see that one. So I also just want to just double check this. Yes, I think the screen bounds might be off the screen. Maybe. I don't know. Let's try something out. Let's say, let's put it at the lower left-hand corner of the screen, and let's just make it a certain size. So let's just say 0, 0, 0, and then let's make one like 20 pixels. So we should see at the lower left of the screen or something. I've tested this before, but let's just double check. All right, so clearly, maybe is it this 1 pixel thing? What was it again? Depth, and yeah, let's say it's 4 pixels big, and then maybe let's make this like 200 instead. So maybe, all right. So it's kind of showing up. That's kind of wrong. Oh no, min max. Yeah, that's good. So maybe the 1 pixel was too thin. Is 1 pixel too thin? Oh, for crying out loud. Kill. Neat. Hey there, Dick Ronan. How's it going? What is occlusion? So occlusion is simply you have a, oh, I lost my whiteboard. or the blackboard, whatever you want to call it. So basically you have an object, and occlusion is when something goes in front of it. So you can imagine, here's an object, occlusion, like this new thing we've just drawn occludes the thing behind it. So we're just trying to figure out how we can write a rough occlusion buffer, which is basically a depth buffer, but with that is not 100% correct. When you sample it, it will tell you something is definitely occluded, but definitely not occluded, right? So that's what it is. Kill all game. Oh, yeah, kill all the game. Maybe that's a better way of doing it. Thank you. My Unix skills are, yes, obviously need some work. Thank you so much, Ross Moscow. Kill all of the game. Yeah, so 1 pixel, it was like, no. 2 pixel. Yeah, we should have frustum culling at some point. We don't have it yet. 2 pixel is fine. 1 pixel is like, no. Well, that's not nice. Why is 1 pixel no? So I think it needs to be times by 2. Let's take a look at it. Let's take a screenshot. Right, close the game. Damn it. Right, let's open this up in Creator or something. Yeah, so what is frustum culling? So frustum culling is basically, you've got the camera, let's draw it. You got the camera, so here's like where the eye is, right? The eye is looking out there through the camera. Here's the plane where the screen sits in this, in view space or whatever, near clip space. Then you've got your object in the world. You've then got another object in the world, right? Frustum culling is simply saying, is this object within the frustum? And if it is, it gets rendered. If it isn't, it gets discarded and doesn't get. We don't try and render it at all, right? So it's a way to cheap cull like tons of objects, basically. Why do we need occlusion culling? Because basically I've got a bunch of I've got a dense set of spheres, and what I've done, I've got like 2 million spheres in a volume, and I want to try and render less than 2 million. So I'm trying to cheaply render something to then say don't render this other stuff because it's blocked, right? And that's the idea. No worries. So it's very helpful stuff. So it's going to allow us to hopefully render less spheres, but that's the idea. And also it can make us say, hey, this whole volume is occluded, so don't render that whole volume. So it can really help, but yeah, we'll see how well we can get this thing to work. Okay, so this is a bit weird. Oh yeah, I took a screenshot. How many pixels is that? That one. It's 1 pixel. Bum bum bum. This was a lie. Okay, so what we need to do then, jot that down to that. This border thickness is a wrong. So you need to multiply where's the 2D one? SDF bordered ABB. So this needs to be multiplied by 2. Right, those were a bit buggered. Okay, I'm glad we've sorted that out. So let's get back to over that draw 2D ABB. We're doing our debugging. Now let's get back to figuring out why. So to see if this one renders. This is one of the occluders. It's a screen bounding box of the occluder. Right, so we see it there. There's the screen box for it. As we get further away, we should see it when it's 8 by 8 pixels. So I guess it's when it's really far away, we should see it show up. Because I'm only rendering one of them. We should see some red, but I don't see any red. Yeah, I don't see any red. So anyway, if I draw all of the occluders, let's just see them all on there. It's so damn slow. Some of them are too big. That's not good. There's something wrong with some of these occluders. They're just way too big. The big ones should be first. So let's step through them one by one. Let's see what the problem is. Right, so that occluder... Also, I don't know why the... It can't handle 32 occluders. Is it handling 32 occluders or is there too many? What is this? I'm a bit confused. 10, 24. That's a buffer overflow. Like we always do in C, because this is the way. Clearly, I wrote that wrong. So this is why it's so slow. Which means... maybe... okay, use the wrong... min with the... not volume constructor occluders, but just volume occluders. So when we construct a volume... we've got we've got 1024 occluders that we look for. They're the best ones. We'll use those. And then we pick 32 of the best occluders. And that's we minned with the wrong value. So we look at that now. Oh, make sure you get 2 pixels. Probably a good idea. Give that a go. Right, so the occluder ray tracer now is actually dirt cheap, which is what I was expecting considering it wasn't a lot of data. So there's still 32 being ray traced there. So that would then mean, if that was 1024, yeah, that is, I think it's about there's 128 volumes maybe? I don't know, maths is not my... Oh, 32. That's about 32 instances on the screen. It will take 0.5 ms. There's some room for improvement still on that speed, I think. Yeah, maybe we can reduce the number of occluders and just pick a smaller amount, and that can also work. Yeah, try 2, you think, as well. Let's give that a go. Draw. Yeah, so you're saying try, so we tried 1 now, let's try 2. That's looking more than 2 pixels. That's looking more than 2 pixels. It's maybe something to do with floating point then. Must be. No. Yeah, I don't know what that is. It's 3 pixels now. No. Yeah, it's off by 0.5. It's doing a trunk. Okay. Interesting. Thank you, Rosmusco. That would have been incorrect. So what have we done? Try 8. Alright, 8. Wait a minute. Yeah, that's probably what you want. It's the same thickness. Wait, is it the same thickness? Yeah. Huh. Yeah, it's not done any transformations in any way. Right, let's take a look at that 8. It is 15 instead of 8. So it's kind of like, it's 0.9 if you will. So it kind of feels like maybe it's like epsilon, off by an epsilon or something. I don't know. Ah. Less than or equal to 0 maybe? Is that what I'm missing? Right, so you're saying add 0.5. You think? You probably don't even need that. You probably need a tiny amount. I don't know if it's the less than. It might be less than or equal to 0. That's probably the issue. Is it really landing? Let's try the 1 again. Right, that shows up now. Well, why does that show up? It looks too thick as well. That's not 1 pixel. More like 2 pixels that now? What have I done? I am so confused. So maybe this needs to be halved? I think that's more like 1 pixel now. Hmm. Alright, so open that up in Korea. I think that's right. We'll try the 8 pixels after. Yeah, that's 1. How strange. So, in here. In your honest opinion. Better to use 0.5. Oh, stay away from the thresholds, right, okay. Yeah, but we're not doing any truncating though. I see what you're saying. Yeah, as an offset, yeah. So plus 0.5, yeah. I get what you mean. So, the other one's wrong then. SDF. Alright, that's fine. Tells the vector, circle, ABB. Okay. So, right, so let's try the 8 one more time and then we'll see all of the boxes and they should be fine. Then we'll debug some other variables. That's 8 pixels apparently. Let's just check that quick. Um, 5 pixels. What? Because I halved it. This ain't good. What is the lore of this game? I kind of got a story written up. Right, I'm gonna draw 2 boxes now. Yeah, I got a story written up. In the repo somewhere. But probably is gonna have a revision. Yeah, I haven't really touched on it on stream yet. Right, let's just try that as a test. So this ABB thing. So maybe let's try what Ross Musco was saying, because he's the maths guy, and I'm not the maths guy. And Ross Musco knows it all. So he's saying offset it by 0.5, and that ought to be good enough. So let's try that out. So here's our 2 screen bounds. That's definitely not 8 pixels. That's 16 or more. So maybe we need to... Something really wrong with this. Yeah, because if you're 1 pixel away, you take away a pixel, right? You're at the edge. If you're less than a pixel away, you take away a pixel, right? But it is kind of rounded. That's probably yeah. So if you're 1 pixel on the inside or something like that, you're inside the shape by less than a pixel, less than or equal to a pixel. Make it positive, then take away a pixel. So I think when it's like a pixel and you do all this stuff, it ends up being off by like an epsilon or something. So that should be right. Let's Is everything gonna be ray traced? Probably. Yeah, it's just easier. Plus, it allows us to do some fancy effects and stuff. Yeah, we're ray tracing everything at the moment. Haven't needed to write anything else. No, we've done sign distance fields for 2D. We do a lot of sign distance fields. We've got a custom UI renderer as well. Purely sign distance fields. Maybe that is 8. Okay, it's 8. I'm sorry, Ross Musco. I apologize. That was correct. This is the way. Ross Musco. You amaze me. Alright, thank you, sir. Appreciate it again. This is why you have the gem. Right. So back to where we were. We're trying to debug what the hell's going on with this occluders. So we're getting the screen bounding box of these 3D volumes, which are axis aligned in local space, and then they're not axis aligned in view space, and then you've got the bounding box, the outer bounding box around that. So we render all of these. Here they all are. They're screen bounds though, and they kind of jump all over the place because I've got a silly... It's not deterministic, and I reconstruct the volume every frame because I want to see stuff like this. And I wasn't able to fix the problem earlier, but we're seeing the screen bounce. So we should be able to see stuff being in red there, but we're not. Is this general purpose engine? Do you have a game in mind? I've written a game design. I wrote that like 2 months ago, but for the first sort of like 6 months of while I've been working on this on the side, if you will, we were writing a lot of the base part of the game engine for the game. But I was just writing all the sort of core things that you would need. So I've got like a core section where we've got growable arrays, hash tables, and object pools, custom allocators. Operating systems, this goes keyboard, mouse, gamepad on Windows and Linux. And that's it for now. Maybe files, virtual memory, that stuff. Yeah. We've got custom UI, which is immediate mode, which is what I want to use for whatever game I'm going to use. So we wrote that as well. Got a GPU abstraction, which is just compute shaders only. We're trying to do this all with just compute shaders. And not using any of the triangle rasterizer hardware. And then this is the section we've been spending most of the time in now, which is basically we're trying to find a kind of unique art style with just rendering spheres, but the spheres aren't kind of static, they move around and stuff as well. So we're trying to get this rendering at a decent speed and also do all the stuff as well. Do you do embedded? No. I do 3D graphics as a career. Yeah, so we've just been writing the sort of core foundations of an engine, which is probably what you would need in a 3D game. I know I wanted a 3D game. I wanted to do, and So we kind of got all that together. Now we're just trying to find the art style. Then when we've got the art style, I'm going to look at my game design, which I wrote a month ago. I kind of thought about what I want to do, but we'll see how I feel about it later on. I'll probably come up with some more ideas and pick the best one and then go towards that. But right now we're just trying to find an art style because that's what I want to have first, basically. So yeah, we're seeing the boxes, which is good. So let's follow around Occluder 0. So Occluder 0, what else do we want to know? What else do we know? So let's draw a vector of the width and height. Oh wait, let's draw the screen bounds after. Yeah, probably right now. So let's draw it before and after. And let's do it like magenta or something, you know. Bit of magenta. Let's run to that. Right, so clearly there is no magenta. It don't exist. Why the 8s? Get out of here. So clearly this gets fired, and I wonder if anything gets past here. Should we just try that? Oh, they're all down there. Look at them. Beep, 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 beep. They're all little tiny things down there. So that's a bit weird. But I don't know what the box. Yes, they're rendering at different MIP levels. But you would expect to see it. Something's a bit weird. So as they get smaller, yeah, so the reason why you saw them down there is because that's what it is on the lower MIP level. Which is alright. But when it gets to like MIP, should we do some GPU prints? You know, let's just do like if occluder index equals 0. MIP that. What else? We could do the screen bounds. U, and U. So MIP screen bounds X, Y, Z, W. So let's see that. We're just going to see occluder 0 and just look at that in the terminal and be like, So I can't really see it from here. But yeah, let's see what that one says. MIP is 3. It's got a width of 8 pixels and a height of 6 pixels. That should be on the screen. Do I see you on the screen? Maybe I should render it 2 pixels big or something. Too much stuff in the way. Oh, it's not showing up anymore. Oh, the width and height. Wait, what happened? Oh my days, that's wrong. That should be Y. That's why. All right, so let's see the boxes. Already running slow. Right, so the boxes are getting bigger. All right, it's too many boxes. Too many boxes. I don't know how the stream's coping because it could affect OBS or something if I'm not careful. So let's just right. So seeing there's the magenta box in the lower left. It's popping up and up and up. So we should see something show when this box gets to 8 pixels. The box is still on 8 pixels. Seriously, what's going on there? It should show up red. Because we should be rendering the we should be rendering so what we should be seeing on the screen is the depth, and we're only seeing it in the lowest MIP. I haven't done the propagation code yet. I've got that somewhere else, so I could just plug it in. But I want to see it work on the first MIP first. So that's surely small enough, right? Let's take a look at that. MIP 1, whoops. Right, so I guess it might not render because it's less than 4 pixels here. No. Less than 2 pixels. Yeah, okay, so that's fine. It's 3 pixels. So it wasn't small enough. All right, so I think let's do the propagation code. And let's try that instead. You know, I want to. You know, should we see if we actually write pixels? Let's do this, right? We only show this on the screen, so if it writes a pixel to the screen. Let's try that. So we don't see anything at all. This never writes to the screen at all, or to the occlusion texture. Specifically that one. Shall we try and see if all of them will do it? Okay, specifically none of them even get there. So why is that? What about here? They don't even make it. Okay, one of them makes it inside there. Oh yeah, sorry, it's meant to be that one. Okay. This one makes it inside there. Global screen dims. Oh, you bugger. What did I do? That coordinate is scaled. Whoops. This needs to be screen dims at. So that was kind of right out of bounds in the MIP. Still though, I would expect to see something show up. It's not entirely that fault, is it? Okay, so still rendering. Renders, apparently. Well, not renders, it gets this far. So after this though, the Rayverse whatever doesn't land for whatever reason. So let's do another thing. We're now going to draw this object in 3D. So 3D, we're going to draw an ABB or an OBB. So we need to find one that I've made earlier, probably. All right. So the transform is going to be from view. Yeah, view from local, center position in local space, half dims in local space. Ought to be good enough. So let's try that. We're going to see it in white. So this should be the occluder. Wait, why are we seeing it in white? I don't see. Oh, there it is. As I get close enough, I see it. Why? Oh, it's got the depth, the damn depth testing on it. Let's remove that. Let's remove the depth testing on that one. So it always renders on top. There we go. So, okay, so you see in the screen bounding box, it goes around that occluder, right? Good. Good. So, why then, so, what are we doing? So vector. So ray direction in view space, we got that, yeah? So if you're doing view space, the issue is, yeah, we're doing like, yeah, Why don't we move the ray direction into world space? And then we can debug draw that maybe. Yeah, so something's a bit messed. Something's been messed. So this is always failing, I think. Let's just double check that. So I'd only debug draw this if one of the pixels. Oh. Oh wait, there's one here as well, damn it. Wait, is that before and after? Shouldn't we be seeing two of them? Oh yeah, sorry, the magenta one. Oh yeah. So we should be seeing the OOB, the OBB, the oriented bounding box that appears in the middle only if it writes a pixel, which it's not doing it. At all, which is a bit of a bugger. So this fails badly. Horrendously. It fails. Center position in local space, we're drawing from that towards that from there. What's the problem with that? It's pretty legit. Pretty legit. I can move these into view space and then debug draw those. I can move into what? Yeah, view space works too. Let's debug, draw that. So position in view space, let's just say 0. Wait, do you want a view space? Or world space, probably world space. This one. Mol P. So the point we want to move is oh no, so from the middle of the world to, what's the P again? Center position local space. We'll move that. Yep. Into world space. Thickness, I don't know, 1. Probably too much, but anyway. Color. Green. Z test, no. So let's just see if it gets the position. Did you swap the ray origin and object origin? No, I'm pretty sure that's correct. Wait. You need to be going towards the... Oh, wait a minute. That's a vector going towards the center. Instead of a vector going towards the... Yeah, that is wrong. Good point, Rosmusko. Because this ABB versus ray assumes that the ABB is at 0, 0. So, yeah, towards that from that, yes. Whoopsie. Right, it's rendering the box now, which means it's correct. I don't know what's up with my vector, I've just tried to debug draw, but that box is showing up. Wait, no. Hang on a minute. Hang on a minute. I jumped the gun. Okay, the box shows. It's being rendered. Excellent. So when it gets small enough, it will show up red. I can't see it though. It's just... I didn't see any pixels. Maybe there's too much debug draw stuff on it as well. It's hard to know. Yeah, what one was that at? It's still at MIP1 apparently. Wasn't big enough. Right, so it's rendering now. We know that. So why don't we plug in the downsample code and just see how it works. So I've already got this code. It's somewhere else though. We just got to move it. And it was called like... Is it downsample? So essentially what we have is a MIP chain where you've got like a full MIP chain, I think, or maybe not. You basically got like a depth pyramid of textures where they're all sort of, each MIP is half the other one, obviously. Something like this. So what we need to do is we've maybe written some occlusion buffer into there, some occlusion buffer into there, and some occlusion buffer into there. We need to make it so all of these occlusion buffers are visible on any one of these. So this one ends up filling a smaller portion of this one. This one fills a bigger portion on this one, right? And you know, so we need to sort of like basically we're going to downsample this all the way up to here, and then we're going to upsample all of this down to there. And that's the way we did it in the previous time, so I'm just going to copy that code over. Pretty sure it worked. I don't know, we can double check it. Just got to find it. Right, occlusion right, then propagate backwards, propagate forward. These are my boys. So we'll take these. Just got to find where we write this. Oh no. So maybe render.doc could help us, but I don't know. Here. So here we want to dump it. Hopefully that works fine. So this is going to propagate backwards from the highest res to the lowest res, and then propagate forward from the lowest res to the highest res. We'll see how that goes. What font is this? Liberation Mono. Right. So we should be seeing something. Oh, I see pixels. So something's working. This is definitely buggy though. We shouldn't be seeing two. Oh, now we're seeing three things. Well, this is not what I expected. So I think the propagate things are kind of. Yeah, so what's nice about it is it's kind of cheap, right? You've got, you know, that's the biggest one is as expensive as the current occluders. But I don't know, when we start putting more shapes, so this should be constant, right? But the more occluders, the more instances we add, the more that will rise later on. So yeah, there's that. But I'm thinking we can still use the information from the previous frame. We've got to reproject the pixels, and then that mixed with a few occluders that we sort of do that we render on as well, should be good. We just got to see then. It should be really cheap. We just got to see then how many milliseconds that will save us in the actual main render thing. So yeah, I think this is a bit wrong then. This propagate thing at least. I don't know. What could it be that's wrong? That's the question. So as you go further out, oh, so it's kind of upside down. That's the first problem we're seeing, and that is because I've got my damn. It's probably the rendering. Oh wait, which one though? This needs to be. Yes, this needs to be flipped. First problem. We need to flip the Y. So yeah, like this. But it's not screen dims. Instead, it's the dim of the MIP. Now that might be off by 1 because I've literally just divided it, and that could be wrong. It kind of feels way wrong. I don't know what that is. I just flipped it and it's still. There wasn't just the Y that was wrong, the X2. We could scale these back. Oh no, not really, because you've got integer division. So maybe the I was thinking the downsamplers might have to flip, but no, they don't. So you flip the coordinate here, and when you read from it, maybe did I flip it? I don't know. What did I do? So this is our debug drawing on the screen. We're just putting it on there instead of the spheres. We're just putting this text on there instead. I think I should have. Yeah, you want to flip the coordinate, read it, and it's already flipped up here. Yes, it should be alright. The problem with rendering in pure depth is not really good, but let's just say it's like, let's divide it by maybe, I don't know, 256, and that will get us a good kind of scale, I think, maybe. Make it look softer, right? Right, it's still a bit far. Maybe, right, and that obviously doesn't map to a smooth shade then, but... So there's something wrong with the MIPS. Maybe the addressing or the downsampling. I'm not sure exactly. So you're seeing it repeat. So I guess we can open up in RenderDoc maybe. Maybe you can just do something like this. So we should see probably, let's just take a look at that right there. Gotta find the right pass now, this is bloody annoying. I should really put those tags in, those debug tags. But I don't know how much this tool can really pay off. There's some downsampling, I reckon, somewhere around here. Occlusion texture. Oh, it's near the end, okay. That's the propagating. Right. Propagate. That's the clearing. And that's the rendering. Oh, you have to punch in a real big number. Got to view properly. Alright, so we've seen it show up there. MIP3. So it's when I wrote it, it's wrong. It's picking MIP3 and then rendering there. So that leads me to believe the coordinates we're writing out is wrong. So, okay. So why? Why are the coordinates wrong? So we divide a MIP plus 1. So if you're at MIP 0, we divide by 1. If you're at MIP 2, we divide by... Oh, 3. And 4. But it should be powers of 2, right? So what you should be doing, not dividing, you should be shifting. And shifting down. Right. So divide by 1 would be MIP 0, divide by 2 would be MIP 1, divide by 3, sorry, divide by 4 would be MIP 2, and that will work better. Yeah, that was probably that issue. Hopefully there's not too many more. So let's render that. No, I'm not seeing. Oh. Right, so they're showing up there. Interesting. Let's get in the right area. Okay, so we get far enough back. What is this one? Did we do the Did I already get rid of all that debug code? Watermelon. Watermelon. That's not good. I had some printing code and everything. But as you get too close, it just doesn't like it. I don't know why that is. So let's undo until we find all that debug code that I had. But I just deleted all for some reason. I keep doing that. So I want to see like, hey, I've written out the pixel. Can I see this stuff, please? So I was hoping this would write out some pixels, right? There's so many. I need to group these at some point, and maybe I need to have a different buffer filled with my performance stuff. But yeah, we don't see it write out anything. Weird. Why? So let's move it out here. Oh, that's still doing the divide, damn it. Right, let's keep that in there. That's good. I like that one there. So this should be doing a shift. Bit shift. Wait. Shift right. Yeah. Just MIP. Boom. Let's try that out. A bit. So yeah, it flickers because the occluders aren't consistent. But yeah. At least they're showing up now, kinda. I don't know. Some of these are not even bothered showing up. So this would mean they are at a pretty high MIP. And they don't end up downsampling right. So I don't know, are they even, or they don't make it into the right. Yeah, this would mean the MIP might go out of bounds as well. We haven't really accounted for that. No, I think I'd do a full MIP chain. Yeah, I do a full MIP chain. So I think the problem is that I don't know actually. I don't remember the problem. There. See why that one didn't work when it's like a bit close. So it should be printing. Oh, unless it doesn't do this. Oh, interesting. It fails that block as well. It's saying it's less than 2. So I wonder what we did there. Screen bound 0. MIP 20. That's definitely out of bounds. MIP 20. What's this biggest dimension? Maybe the way I'm calculating that MIP thing is wrong. Potentially. Let's see what the sizes are there. Somewhere right here. Right, the sizes are, so it's calculated like MIP 13, which probably doesn't exist. What's that bounds then? The x, y, end x, end y. Um, so I guess you want to clamp the MIP. But then why? No, something's wrong. Oh, okay, so the way I'm calculating the MIP now is definitely wrong. That would mean... So I'm thinking, how many times does this 8x8x8 fit into the biggest biggest width or height? Oh, I did the damn thing again. Did I undo the... Oh, it's a copy paste error, and I never fixed it. Damn it. Right, still the same problem though. Yeah, still a similar problem, but... So the way it's calculating the MIP, so MIP 21. I have 21 MIPs. So maybe it's a similar thing. You need to do power 2. So we're thinking, how many times do... So we've got this sort of like 8x8. I'm trying to think, how many times does it fit? Yeah, it's not times, it's like a power of 2 thing. Or it's a exponent. I don't know, 64. Wait a minute. This is a function I'm thinking of. No. Probably log something, isn't it? Reverse of... We're on the reverse of a PAL. But log will be log 10. Maybe it's the log 2 of this. So if you can fit... So if it's 64, it'd be 8, right? Obviously not MIP 8. That would be probably 5 instead. So it might be a log 2 of the result of that, because that's how many times. I think it's log 2 of that. I think so. Right, there we go. That works. Alright, so we're seeing it. Yeah, so they get darker because it's closer, right? So we're seeing occluders show up now, which is quite nice. They got holes in, right? They're kind of rough. You know, I've not selected the best occluders yet, so we could probably get a much better thing. But we're seeing, at least we're seeing it here, right? So that's really nice. It jitters a lot. That's because we're recomputing the volume every single frame, and it's just not deterministic. We tried to make it deterministic today, but we kind of failed in that. Maybe another glance at next stream would be a good idea, but we're seeing occluded areas of the screen, which is good at least. So we could probably occlude spheres at best. I want to be kind of occluding whole clusters really. So we need to think about how we can improve this to be even better. But when you get this far away, that's some good occlusion, I think. Just it depends which ones we're picking, but it doesn't seem to be wholly. Whereas when you get closer, I don't know, it really just depends on the angle. Ooh. So when you line up the ABB, it's not good for some reason. So that's probably because I don't know why that is. There's something, I guess we can go diagonal, it's real good. Basically. Yes, I do have a most significant bit function. I could just use that actually, innit? Bit LSB. Wait, most significant bit. Of course, because it's there, innit? Russ must go doing it again. It's interesting. That's where I just try your stuff and it just works first time. Thank you so much, sir. I completely forgot about that. Russ must go. I would give you another gem if I could. Yeah. So, what's taking all this time? My frame time. Oh, it's all that debug printing probably. Nah, I can't. What shader's doing it? We've got like 11 milliseconds right now. What was buggering me up? Right, sort occluders is 5 mil. Okay. Might need to improve that. Wait. Why is sort occluders? No. Or is this because I'm running OBS at the same time it jumps? No, it's consistent. Right, so there's the 5 milliseconds on the sort, on that crazy sort thing we made. That doesn't matter if it's slow really, because it only should run once when you construct the volume and put it into GPU memory. It's not a problem. Just got a couple of 1s and 2s here for the debug draws. But the occluders render, I think I'm happy with that for now, but it needs to get better, I think. Because we're going to be adding more instances. But yeah, this is probably alright, all this stuff. It probably accumulates to 0.05 milliseconds maybe. That won't be so bad. Quick. And we're also kind of rendering at a lower resolution right now. That's another thing. But yeah, so at least we've got some occlusion now. I want to try and occlude clusters, but I think the next thing we should do is improve the selection of the occluders and also solve this determinism problem, because like it's jumping all over the place and it's annoying. I want to run this every frame still. And then we can hopefully occlude full clusters, and we should be able to see this tiled ray tracer get some performance gains, hopefully. That's the plan. And then we should probably populate it with a depth buffer from the previous frame. Maybe we'll start off with that, actually. And reproject it. And then use the best occluders from this frame. And that will be good. And that should be a good depth buffer. So the only problem is on the first frame, you're only going to get the occluders, or when something pops in, you're only going to get the occluders that we've rendered just now. But I think with the information from the previous frame, the depth buffer from the previous frame, if we reproject it, it should be okay. There might be a problem when you take away an object. It might be wrong for a single frame, but that could be okay. I'm not sure yet. Yeah, with the information from the previous frame should be a big help. I just wonder how many visual glitches we'll get. But that should be, this combined with that should be good. Okay. So I guess we made some good progress today. Spent a lot on that sort function really, but at least we got the occlusion buffer rendering to some reasonable degree. Yeah. Yeah, I think I might upload that. How does it concentrate all this time? I don't know. It's a big. It was a bit harder today. I don't know. I felt really tired earlier. I had to take a quick 5-minute break to sort of reset. The biggest one is get good sleep, exercise, eat healthy. You want to also, when you're working, try not to think too hard. The biggest thing is when you think too hard, or maybe when you try and picture stuff in your head too much, it gets very draining and you get very tired. So drawing stuff like this really helps out. Helps you not use your brain too much. Another thing is, yeah, take short breaks. Another thing too. But yeah, and maybe get the odd Pepsi or coffee, I guess, but use that sparingly. But yeah, I'll next be on Tuesday at 6:30 p.m. GMT +1, and we'll do some more occlusion buffer stuff, and we're gonna plug it in and see how good it is and see if it's worth us using, basically. Let's find somebody to raid. Somebody to raid. Somebody to raid. Yeah, avoid distractions while watching streams. Yes, exactly. Yeah. But also don't do that so you can help me, you know? Oh, maybe stream your work. That's another one. Especially programming in C, stream your work. Let's raid Tad. Tad is a work colleague of mine. Let's give Tad a raid. He's doing some dream stuff. Alright. Well, maybe he's not doing dream stuff. He's got the tags still, that's funny. He's doing some CPP. Right. Enjoy, folks. I'll see you all in a future stream. Have a good start to your work week. And yeah, thank you all for coming. Appreciate it. Right, catch you later.